Linux is a very powerful operating system. It is very commonly used, and it's something that most likely you will run across in your journey in cybersecurity if you haven't done so already. It is so popular, in fact, that on top of everything that we're doing inside of the Cybersecurity 101, the CySec 101 series, I'm actually working on another complete training series on the Linux Plus certification, which is completely separate from this, so I don't want people to get confused by this. This is part of the Cybersecurity 101 pathway of TryHackMe, and it just so happens that it's happening all at the same time. So most likely in the upcoming weeks, you're going to get a very strong education in Linux and how it applies to cybersecurity and hacking and ethical pen testing, all that good stuff. So what we're going to talk about today are the absolute fundamentals. We're going to be talking about the history of Linux, which is literally one of the most popular operating systems in the world. It's used in smart cars, Android devices, supercomputers, home appliances, enterprise servers, web servers, a lot of other examples as well. And you'll see more of that when we get into the Linux Plus certification series. And what we're going to go through is essentially running our first series of commands in an interactive Linux machine, teaching you some essential commands used to interact with the file system, and show you how you can search for files and introduce shell operators. So this is the basics, Linux fundamentals part 1. This is a part of a 3-part series that goes inside of the TryHackMe Cybersecurity 101 training series. So without further ado, let's get into it. A bit of a background on Linux. So where is Linux used? It's fair to say that it's a lot more intimidating to approach than OSs like Windows, because Windows has a GUI, right? It has a graphic user interface, a graphical user interface. So you can click around and there's a lot of point and click and you see things. When you think of Linux, more often than not, you think of the command line, and it's basically this black screen with a bunch of text on it. And for people who aren't familiar with just computers or really system administration in general, it can be intimidating. There are advantages and disadvantages to both of the GUI and command line interface. So for example, Linux is much more lightweight, and you'd be surprised to know how there's a good chance that you've actually ran across it in websites that you visited, the car entertainment or control panels inside of vehicles, point of sale systems, as checkout tills and registers in shops, critical infrastructure like traffic light controllers, industrial sensors. It's used literally everywhere. And the fun part about it is that there's a lot of the fundamentals of Linux that also run in OSs like Mac, as well as maybe not the syntax itself, but there's a lot of commonalities that you'll see that also runs across inside of the Windows operating system as well. There are a lot of flavors to Linux. We also call these distributions, or it could just be something people refer to as distros. They are based on Unix, which is another operating system that kind of came before Linux, and it was amplified a little bit, and it was developed by the ultimate father of Linux to become what it is today. Because it's open source, there's a lot of variants that have come in all shapes and sizes. So for example, we have Ubuntu and Debian, which are some of the more commonplace distributions because it's extensible, meaning you can run Ubuntu as a server, such as a web server or a web application, or you could run it as an actual desktop computer. So what we're going to be doing in this particular series especially is we're going to be using Ubuntu. And it runs on systems with only 512 megabytes of RAM, which if you know anything about RAM, 512 megabytes is practically nothing. Most computers these days start with at least 8 gigabytes of RAM. So to be able to run on 512 megabytes of RAM, that means that it's very, very, it's lightweight, as they referred to earlier, or I forget what the technical term that they used was, but it's very light, right? It's something that can run with very little operating power. So since there are different versions of Windows, like 7, 8, 10, 11, etc., etc., there's also a lot of different variations and versions of Linux. So the first question that we have here is, what year was the first release of a Linux operating system launched? And so you can literally, because we've learned the search skills, you could just highlight this and search Google for it, and you'll get the answer right on the front screen right here, which is September of 1991 by Linus Torvalds. And this was 0.02, so it was the very, very first version of Linux. The most official version, which was 1.0, was released in 1994. So we'll talk about a lot of that stuff when we go into the Linux Plus video. I feel like this is kind of setting up everything for us to jump into Linux Plus, because we're going to review a lot of these things again in the Linux Plus video. And then of course we're going to go into a lot of the advanced stuff as well. So this is like a nice setup. This is a nice warm up to get into the Linux Plus video certification that will be dropping in a couple of weeks from the launch of this particular video. So really excited about it. So now what we're going to do is we're going to actually launch our first Linux machine, and you're going to get a chance to see what it's like to interact with it. As far as interacting with the machine is concerned, just for the purposes of this task, anytime that you're using any kind of a virtual machine inside of TryHackMe, there's always going to be a green Start Machine button, and it usually is also implied on the tab itself. So when you look at these tabs, usually there's this green icon right here, meaning that there's a machine that's attached to that particular task. So when you click on the Start Machine, it takes about a minute, maybe 2 minutes, just depending on what kind of machine is being launched. And then it's launched, and then you get an IP address that shows up at the very top right here. So it tells us that it's going to be shown in exactly 12 seconds, which is when it finishes. There's an expiration timeline that's attached to it, and if you want to extend it, you can always click on this button at the bottom right here, the plus button that extends your time. And from there, you get access to the machine itself. And in this particular case, we are looking at literally just the command line version. So there's no GUI interface that's associated with it. And if we were to look at this at the very top, we can see that this is an Ubuntu machine that's been launched right here. And this is just general system information that's available for it. And at the very bottom right here, we get the intro to our command line interface, and we can start running some commands in this thing. So I'm going to keep it inside of this this dual kind of a side screen, double screen right here, because we can technically open it up that looks like this, but it ends up kind of being, I mean, it's essentially the same thing. It's probably best actually to run it this way. So never mind. I retract my previous statement. I'm going to keep it like this, and we're going to look at it in a full screen. And you can accomplish this by just clicking the full screen button at the very bottom right there. And then when you click on the exit split view, then you go back to your normal view like this, and then you can just have your full screen of the Linux machine or any of the virtual machines that they assign you. You can have the screen like that. So that's what we're going to do for this particular exercise. So let's run through our first series of commands. Okay, so for the purposes of this, I have moved that previous tab that we had with the instructions on my second monitor. And on this monitor that you see right here, we're just going to look at the command line interface. And so I'm going to run through the various commands that they give us as I run across them inside of the instructions. And then from there, we're just going to go through our series of questions and answers and so on and so forth. But essentially, I'm just going to read whatever the command is, and I'm going to type it on the screen so you can actually see what the results are on the screen instead of reading it and then coming back and typing it, so on and so forth. So the first notification that we get is that, at first glance, this can be a little bit intimidating, and I can understand, from the perspective of somebody that's looking at this for the very first time. I remember looking at the command line the very first time, and it was also intimidating to me. So I don't want you to think of it as such, because if you literally just keep your mind open for a little bit, you will see how powerful this actually is and how quickly you can get things done, because you don't have to click around and browse. If you know what you're searching for, if you know what you're trying to do, it's so much faster to use the command line. So the very first thing that I'm going to type is the command clear, because I just want to clear my screen. So it just seems that clear or CLS are not available at all. Oh, there you go. I think there was a couple of glitches at the very beginning. But so if I type anything, so let's say I type who am I, it brings this over here. I type ls to list what's inside of my folder, etc., etc. And then you go through whatever you go through. And now you want to clear the screen, you just type clear, and then that will work perfectly fine for you. So clear clears our screen, and we only have our command line now at the very top right here. So easily viewable, and I will even zoom in a little bit more just to make it easy for you to see. Okay, so The first command, the very, very first command that we have is the command which is echo. So echo essentially spits back whatever you assign for it to spit back onto the screen. So this is a string. Everything that's inside of these quotations is considered a string. Even if I put numbers in there, technically, because it's inside of the quotations, it can be considered a string. So when I say echo this string, I'm essentially telling Linux to print it back for me as its response. And you can see that it responds back to me, hello friend, right? And you can do a lot of things with this. It kind of seems redundant, especially the first few times. It's like, okay, well, why am I doing this? Why would I tell it to just print something back for me onto the screen? But you can combine this with a lot of scripting tactics to verify whether or not your scripting is working, whether or not certain variables are working. So the echo command is actually very useful. We use it a lot. We can also use echo hello friend to put something inside of a file, right? So I'm kind of getting ahead of myself, but I want to give you as much as possible. So in my current directory, so if I run pwd, my working directory that I'm in, we can see that we're inside of the home TryHackMe directory, and these are the contents of the home TryHackMe directory. And so what I can do is I can create a file by saying echo hello friend, and then using this arrow and pushing that data inside of a text file that we'll just call file.txt. And then I'm echoing that string to this text file. I press enter, and as you can see, nothing is printed onto the screen right now because, as we just saw previously, these were the contents of our current directory. So if I run it, now there's actually a new file inside of my current directory. And now I can concatenate this, and we'll probably run across this either today or maybe in one of the other fundamental exercises. Cat just prints the contents of whatever the file is onto your screen. So I can just do cat file text, and then it says hello friend because I put this string inside of this file by using echo, the string, and this forward arrow. I guess I call it a what is this? I think it's a greater than sign. So I will use that, and I will say put that inside of the file.txt, right? So if I wanted to do it again, so if I did hello just by itself, and then I'll just do it like that, and I'll do file.txt, what happens is that when we concatenate this, it's replaced our first line. So when you use one of these squigglies, it replaces the entire contents of the line. So if you want to add something to your file, you want to use two of these arrows, and you do that, and that's called appending. So you will append the data into your file, and now you have both of those strings in there. So just be very careful with using this by itself, especially if you don't want to rewrite everything that's inside of a file, because it doesn't ask you, hey, are you sure you want to rewrite this? It'll just execute that command for you. So what you want to do is you want to make sure that you're actually either wanting to completely rewrite it. You got to make sure about that. If you don't want to rewrite it, if you just want to add it to the file as the next line, which we call appending, then you can go ahead and use two of those symbols instead of just one. So that's what we got for echo. Now the next one is another one of those things that's very common. It's like one of those very, very common commands, which is who am I? So you're asking the system to tell you the user information, right? So what user am I currently logged in as? And you can also tell by the way that our command line is set up. It says TryHackMe at Linux. So TryHackMe in this case would be the user, at Linux 1 would be the actual machine that we're logged in as. So I can say who am I is so and so. So if I could now again elaborate or extrapolate on this a little bit more, I can assign the value of who am I into a me variable. And the way that we would do that is I could just say me equals who am I, and let's see, I think I need to actually do it like this, so no spaces. Let's do that. Okay, there you go. So no spaces between your equal sign and your variable content. So I could say me equals who am I, and now I could do echo me, right, and it would print the next the series of content. Actually, so it's now writing this specific string instead of writing the value of the result right here, right? So instead of saying try hack me, because that would be the value itself, instead of doing that, it's just printing back the word onto the screen for me. So the way that we would want to accomplish this is we would actually need to use the very simple modification to this, is that we would just do me, and then I would still do equal, and then now I'm going to create the variable inside of a parentheses, a series of parentheses. And so now this variable is going to equal the value of the whoami command, the response of the whoami command, and it'll give us the actual response that we're looking for, which is TryHackMe. And then we can do this with a lot of different other commands as well that result with certain types of information. So for example, if I did uname, which is the name of the machine that we're on, we can also do the same thing, and you can build scripts this way where you can say, okay, the value of this, the value of who I am as a user is going to be the response to who am I, the value of my machine is going to be the response to this, and then you put all of that inside of a script, and then you run the script, and then all of that information will be printed onto your computer. Instead of you having to run a dozen different commands, you can just run a script, and then that script will run all of those commands and just output that information onto the screen for you. So this is why we use variables. And again, I'm getting way ahead of myself, but I kind of like doing these things just to give you a little bit more information to work with as you develop this this skill set that you have. And when we actually get to the portion where we're going to be running variables and using variables in depth, you will have already been exposed to this information, and it won't be your first time viewing it, and you'll grab the content easier. You'll grasp the content easier, and because it's being repeated to you, it'll click better and you'll understand it better. So there's a reason why I do it. I do want to give you a little bit more than the basic fundamental instructions, because I know that the repetition of it in future videos will really make sure that it sticks and it'll actually be ingrained in your memory. So this is what we have for what we had for echo and what we have for who am I. Those were the two specific commands that we ran in our particular exercise today. So what we have here is the questions at the bottom right here. So if it says, if we wanted to output the text try hack me, what would the command be? So it would be echo and then try hack me. Very, very simple. So what is the username of who you're logged in as on the deployed machine? And we already ran that, and it tells us that it was try hack me. So that is our very first series of commands that we ran with a Linux machine. So now let's go into the interaction with the file system. Okay, as we've already actually discussed a few of these already, so we've discussed the ls command, we've discussed the cat command, and the pwd command. There's one extra one that we haven't looked at yet. So what we're going to do is we're just going to run through the rest of these commands, or we're going to run them a few more times just so we can really get a good hang of them, and then we'll answer the questions that are at the bottom of this screen right here. So it'll tell us some more exciting pieces right here. So let's go back into our virtual machine here, which is our TryHackMe Linux, and then from there we're going to run the commands that we have been told. So the very first one that we want to understand, and I actually run pwd before I run ls because I always want to know where I'm at. And so when I run pwd, it tells me where I'm at, and then I'll run ls, and it says the contents of where I'm at. And then so we can see that we have these files. So there's a log file, there's the file that we just created in our last exercise, and then we have these directories right here. So folder 1, 2, 3, and 4. So what we can do is we can change directory by using the cd command, and then we can go into either one of these things, and now you can see the command line has actually changed and it's added the folder 1 at the end of it. And if I run pwd again, it'll say that now I'm actually inside of the folder 1 directory, and then I can run the ls command inside of the folder 1 directory, and there's nothing in it. It's technically empty. There is something that gets added to ls to actually show you the hidden files that may be inside of this thing that you may not be able to see by just running a basic ls command, and that would be la. And in this particular case, there's actually nothing inside of this file at all. There are no hidden files and nothing else. what we do see is these two entries right here, which is dot dot, which represents going back one directory inside of our hierarchy. So we would go from folder 1 back into TryHackMe, and I'll show you what that looks like. And then the dot represents the current directory that I'm in. So if I had a script in here and I wanted to run it, for example, I would do dot / and then the name of the script, if there was actually a script inside of it, which means I'm implying that I want to run, that's the entire path that I'm in. I want to run this path. That's what the dot represents. I want to run everything inside of this path and / whatever that file is inside of it. Since I don't have anything inside of this, I can do cd and do dot dot, because I have this right here, and that would take me back one directory, and you can see that the command line has now changed. And if I did pwd again, and now we can see that we're inside of the home TryHackMe. If I do dot dot again, I'll go into home, right? So I'm no longer inside of the TryHackMe user. And you can also see that this squiggly line right here has changed, and now it's a / and it's inside of home. So if I do pwd, now it says my current directory is / home. And if I do ls, we'll see that we have actually two users inside of our home directory. And the home directory has all of the contents of the users inside of that specific machine. So let's clear this up and do ls one more time. And now we have TryHackMe and Ubuntu, which are our users. The user that we're supposed to interact with is TryHackMe. So if I try to go to Ubuntu, I feel like, oh, I can go into Ubuntu. There's nothing inside of Ubuntu, and these are the hidden files. So now you see when we do lsla, we actually have hidden files that do show up here. And you have the bash history, and we have the bash logout, the cache profile, SSH. These are all beyond the scope of this room, so I'm not going to go into that because it's just not worth it to try to spend time on that right now. We're literally doing basic fundamentals. So what we're going to do is we're going to go back one more time, and then we're going to go inside of our TryHackMe user one more time. And now we have these contents of this folder. So what we've covered is pwd, which gives us our working directory. It prints the working directory. We've covered ls to print the contents of the screen, and then, or the contents of the directory, excuse me. And then we've covered cd. So if we go into the folder 2 and list it, there's nothing in there. Let's go into folder 3. There is nothing in there. So let's go into folder 4. And okay, there's actually a note inside of folder 4. So now we can use our last command in this particular task, which is cat, so which stands for concatenate, which essentially prints the content of that file onto our display here. So if I do cat note.txt, it'll say hello world. So it's actually very similar to the note that we already created with file.txt, which had hello there, so on and so forth. So it actually has these various strings inside of it. So now we've covered all 4 of these commands, and you've seen me use it multiple times, and hopefully you're also doing this on your own virtual machine, or maybe you're inside of TryHackMe and you're doing it. But this also applies to the Mac OS as well. All of these commands, so if you're by any chance, if you're watching this from a Mac computer, all of these commands also apply to a Mac computer. So you can do pwd inside of a Mac computer and it'll print your current directory. You can do ls, and ls doesn't apply to Windows machines. Not all of them. Sometimes it actually does work, but most Windows machines have dir that lists the contents of the directory, and you can see it actually works over here as well, but in this sense it doesn't highlight or it doesn't colorize the folders that we have over here, so we can't really tell if these things are directories or files or what they are. So in this particular case, because we know that we're in a Linux machine, what we're going to do is we're going to run ls, and it will go ahead and print these things for us. And if I did lsla, it'll actually again show me everything as well as the hidden files. But then now we can see over here some extra information that would be assigned to the file itself, the date that it was created, the various user IDs or the usernames that were used to create it, the group permissions that are assigned to it, which are, again, these are beyond the scope of this particular room, so I'm not going to go into that. But this is just a nice extension of the ls command for you to be able to at least find hidden files, or to be able to see certain data about the files that are inside of that directory. So we have ls that we've covered. One more time, ls we've covered, cd, folder 4, we covered that. And then we have pwd, which tells us which directory we're in. And now inside of that folder, we have this note. So we can do cat note.txt to print the contents of that note. And now we have the contents of that note. And so if we go into our questions here, I bet you they're going to ask about all of that stuff, right? So it says, on the Linux machine you deploy, how many folders are there? Which were 4 folders. Which directory contains a file? It was folder number 4. What is the content of the file? It said hello world, but there's actually an exclamation mark at the end of that, which I don't know why they didn't accept the first time. And then so use the cd command to navigate to this file and find out the new working directory. What is the path? And we accomplished this by doing pwd. Excuse me, that was so disgusting. I kind of burped as I don't know if you heard that, but whatever, I'm just gonna leave it in. That was so embarrassing. Pwd, and that would print the working directory. That was really bad. I'm sorry guys. I'm so sorry about that. That's so embarrassing. Anyways, let's move on. Let's move on to the next one. Okay, now what we're gonna go over is the find command as well as the grep command, and they're both actually extremely useful, and you will use these very, very frequently. So the purpose of find is to literally look for something that you know exists, you just don't know where it is. So instead of doing cd and changing directories to every single directory and doing ls to find what is available inside of that directory, you can just use find. So in this particular case, we now know that I have the file.txt that is in my current directory, and then I also know that there is a note.txt that is inside of the folder 4 directory. So let's say that I am currently inside of the home TryHackMe, so we're going to clear that over here, and what I want to do is I want to search for anything that is a txt file, right? So I can just do find and then use that as my command to search for the information, right? So what I can do is I can do find, and then I can do name, which means I'm looking for something by its name, and then we'll use the asterisk, which stands for a wildcard character that would essentially be anything. So anything that ends with txt, that's what I want to look for. So I run that and it says, oh, you know what, inside of your current directory you have something called a file.txt file, right? And that exists right there. Something else that I can do is I can do find and then run the /, meaning find recursively inside of the entire thing. So instead of this one, just looks for the file inside of my current directory that I'm in. But if I did find /, and again, I could actually make this a little bit easier for the computer. So instead of doing find /, because what it would do is it would search for everything that is inside of the root, which is represented by this / right here. So it will look inside of home, it will look inside of TryHackMe, it'll look inside of that Ubuntu user as well. So instead of doing that, I can just say find inside of the home TryHackMe by something by the name that has the txt extension, and it'll again still say that. So now I think what I want to do is I want to try to find that other txt file that we have, and now we can see that there's a lot of other information that's going to show up onto the screen because there's so many other files that we don't have permission to access. But there is something on here that you should be able to find ultimately as it tries to continue to look for us. There should be something that we can find. So there's the file.txt that exists on the home, and then let's see if that other file also exists, because we know for a fact that there's one inside of the folder 4, right? We know there's something inside of folder 4. So how do we find what we're looking for and avoid all of these permission denied messages? Because it can provide a lot of noise, and now I can't scroll up anymore because there's just so much data onto the screen. So I know for a fact that I'm not going to be able to find exactly what I'm looking for. So in this particular case, what I'm going to do is I'm going to add an extra parameter, and I'm again kind of just teaching you some extra things that you may not necessarily need right now. We're going to look for something by the name of the /.txt or the *.txt, and then we're going to remove all of our error messages, and we're going to put them inside of our dev null folder. So we won't see anything other than the actual file that we find. But it's interesting that it won't show me what is inside of the folder number 4. That's the thing that I'm very, very fascinated by. So for now, we know that we can use find to find a file. And what I'm going to do is I'm just going to go through the rest of the instructions that we have in this particular task. And then from here, we'll see if there's anything else that might be interesting or of note to us. And then maybe we can find something else that hopefully will help us get the result that we're looking for. So that was find. So if you know that you're looking for something that is a text file, or if you know you can, let's see if we can run the other command that they had, which is something called passwords.txt, right? So they did a search for that and nothing showed up for us for passwords.txt because there's nothing inside of any of our folders that actually have that. So we can go ahead and try to see if there's something else that we can run to try to look for what we're looking for here. Okay, so just because I'm a little bit obsessive, I actually removed that file that I created myself. So now that I run it, we can see that it no longer exists right here. And the way that I did that, I just used the remove command and I gave it the file name, and so it removed the file. So now when I actually run the find command and trying to look for something that has an extension of txt, now for whatever reason, it actually shows me that inside of folder 4, there is a note.txt. So that part is actually interesting to me. I don't know why I didn't list everything that was available, but all I had to do was remove that other file and it worked, it's just very interesting that that's the case. It should bring up everything that has an extension of txt, but whatever. We'll move on. For the interest of time, I don't want to get too caught up with trying to do troubleshooting and all these things, because I have to constantly remind myself that this is a fundamentals room and we're going through fundamentals. So we have found our file using the name.txt, and now it works, right? Everything is fine. So what we can do is now grep. Grep stands, actually it's for searching. It doesn't stand for searching, but it's something that we use to search through the contents of a specific file. So in the actual instructions, they have given us this other command, which is the wc, that actually counts the number of entries that are inside of a given file. And so if we do wcl, we're going to be counting the lines inside of a file. And so we have an access log. So if I do that, now it says there are 302 entries inside of the access log file. So that's a lot of entries for you to try to concatenate, right? So if I actually do cat of access log, we'll see that there's a lot of files over here. There are a lot of entries over here. And this can get very overwhelming to try to manually search through. So what we need to do is we need to find something that is of interest to us. And the way that we would do that is by searching for that entry inside of that file. So this is where grep comes in. So let's say we actually have an IP address that we're interested in because somebody told us to look for anything that had to do with this particular IP address, or it's an IP address that was shown up in some kind of a database to be malicious. So we have to actually create a script that looks for this IP address in any of our log files. And if it finds it, it needs to give us some kind of an alert, right? So we've been given an IP address. In this particular case, the IP address is 81143.211.90. That's the IP address. So that's what I'm searching for. So I will do grep and I will put the entry that I'm searching for. And then I need to give it the place that I want it to search through, which in this case is going to be our access log. So we run that and nothing, for whatever reason, it doesn't exist. So 143.211.90, 81143.211.90. In my particular case, it does not show up anything. So that was the command that was ran, and actually the exercise that we have, or the instructions, right? So what they did right in this particular case, they actually grepped for that IP address and they got a response from it. But in our particular case, there was nothing about that IP address in our log. So that's not applicable to us in any kind of way. But for the question that we need to answer, the first one is that use grep to search for the prefix of THM inside of the access log file. So I can just do grep and I can run THM like this and then do access log and see what shows up, and there it is. So get THM access, etc., etc. That is the line item. So instead of going through all of those 300 line items that we found, we can just grep for the piece that we're looking for. And in this particular case is get THM access, which is the answer that we're looking for, which in this particular case, I've already done this room, so it already exists here. So use grep on the access log to find the flag that has a prefix of THM, and what is that flag? And that is our flag over here. So it's, fairly, very simple. They don't give us too many things to do. I like to go off script, and I like to do things and do side missions, so to speak, which is probably why that initial find command didn't work, because I did the side mission in a previous thing and I created a file when I probably shouldn't have created a file, and so the system couldn't find the file. So that's how it worked. So now we can move on to our next task, which in this particular case are the shell operators. Okay, so what's nice is that I've actually covered these two operators down here, so you should already be familiar with them. And we can now talk about the full list, and then you'll get another review of these two operators. So we have the ampersand operator, which allows you to run commands in the background of the terminal. You have the double ampersand, which allows you to combine multiple commands together in one line, meaning it'll run multiple commands at the same time. You have the single greater than operator, which is a redirector, meaning that we can take the output from a command, like using cat to output a file and redirect it somewhere else, or using echo, for example, to redirect it somewhere else. And then you have the double, which the same function, but it appends, meaning it adds to the file instead of rewriting the contents or replacing the contents of that file. And so these are our operators. So we can run the various commands that they've given us in this particular case to try to kind of go through everything that we got over here, and then finally answer the questions that we have at the bottom right there. So let's go through the various commands that they've given us and just try this out a little bit. Okay, the first one is the operator ampersand by itself. And in this particular case, we don't actually have a command, but I do want to kind of show you a sample command of what that looks like. So essentially what it does is that it allows you to execute a command in the background. So for example, let's say you want to copy a large file and you know that it's going to take a really long time. And because it's going to take a long time to complete, you won't be able to do anything else until that file is completed. Meaning, since you're in the command line and you only get one terminal, you only get one command line here, until that command completes, you won't be able to do anything else. So what you want to do is you make that command run in the background so that you can still use the terminal to do other things. So this is what that might look like. So copy stands for copy, or CP stands for copy, I should say. And actually, let's look at this. So let's say we have the access log, for example, right? And I want to copy it to folder 1, and I don't want to do it in the foreground. I want to do it in the background. So what I would do is I would do CP, and I would do the access log, right? I want to copy that file, and I want to copy it to the folder 1. So I'll just do /folder1, and then I'm going to do and at the very end of it, so it runs in the background. And then that's it, right? So if I should go to folder 1 and, cd folder 1, and if I run what the ls command would be, now it's been copied and it's inside of the folder 1. And this wasn't a massive file, so it happened instantaneously. But if it was a massive file, I wouldn't be able to use my terminal until that copy was done. But because I did the ampersand at the very end of it, so let me just show you the full command one more time just so you can see it. Since I did this ampersand at the very, very end of it, it ran in the background, right? So that's the piece that is very useful in this particular case, and that's what you need to know, is that you just put ampersand at the very, very end of it, and it'll just run everything in the background. So that's the piece that that's how you apply this particular specific operator. Now the next one is the double ampersand. So you have two commands that you want to run, for example. And you can combine those specific commands to make life a little bit easier. So instead of running the single command, you can run two, right? There are a few ways that we can use that. So we haven't been given any examples. They just said that, you can do command 1 and command 2. But let's say we actually want to, for example, create a new directory, right? So I can say make directory, and I can do new directory, right? And so let me just do it all in one word, because it can get kind of confusing because it doesn't show underscores when you're inside Linux. So it looks like it's an empty space when it's actually an underscore. So you do make dir, so make directory to create the new directory. And then I want to go into that directory. So I'll do cd new directory. And then you press that. And then now all of a sudden we're inside of this new directory right here that previously didn't even exist, right? And so there's nothing inside of this new directory. If I go back and run ls, now we'll see we actually have this new directory at the end right here. So that's very interesting, right? That's how you can run that and actually run multiple commands at the same time. But let's say you want to run 3 commands now, which is kind of an interesting thing, right? So I can do touch my file. So touch my file.txt would be one command. And then I can do and then I can do echo file created successfully, which will just print that onto the screen, right? So I'll get a notification from the system saying, oh, the file was created successfully. And then I can do another series of and commands, and I can do cat, or well, I'm not going to be able to cat really anything because it's going to be empty. So what I can do in this particular case, I can do another echo. I'll just do another echo, and then I'll just say contents, and then I'll put that inside of the myfile.txt. So let me just show you what that looks like, right? So now I've echoed another echo command, and that puts the string contents inside of the myfile.txt. And now I can go ahead and cat the myfile.txt, and I should be able to see those contents in there. So I've created a file, and I've echoed file was created successfully. So this just prints onto the screen just to give me a notification that it did what it was supposed to do. And then I've echoed contents inside of that file, and now I can concatenate or print what's inside of that file onto my screen. So I run this, and we got 2 things, right? So the first one was file was created successfully, which is our notification, and then it actually echoed contents to that file, and then it printed that onto the screen. So you can chain multiple commands together by using and. That's essentially the whole purpose of the double ampersand. So now we can go and cover the other 2 operators, which we've actually already done, right? So I've done the specific for the first one, which is this piece right here, this a greater than symbol that puts the contents of something inside of the file. So now what we can do is we can apply that. We can apply multiple strings together and concatenate this to the original file, right? So what we can do is we can replace. So I'll do the first one as a replace. So instead of being contents, it'll say new contents. That'll be the replacement. So we should not have contents as the first line. So we have echo new contents, and then what we want to do is we want to also echo additional, so contents. And instead of doing a single, because I know it would replace it, I'm going to do another one. And again, and oh, actually, you know what? I need to tell it to echo those contents inside of something, right? So it's going to the new contents. It's going to, I need to fix this piece real quick. So it's going to be new contents, and it's going to be echoed inside of the myfile.txt. So that's going to replace the contents of the file. There you go. And now I have the new string, which is going to be additional contents, and I'm going to add that to the second line of the myfile.txt. And then once that's all done, what I want to do is I want to cat that contents onto the screen, which is going to be hopefully these 2 strings. It should be new contents and on the next line it should be additional contents, and both of those should print onto the screen, and voila, there we go. So we have new contents. So when you do this single one, it replaces everything that's inside of that file, and then when you use the double right here, it adds it, it appends it to the file, as we can see right here. And now we did a chained series of commands, which is used by the ampersands and the operator. So a very, very useful series of commands right here. And now we've officially covered all of the contents of this particular task. So we can go back and we can try to answer these questions that we have right here. So the very first question at the top says, if we wanted to run a command in the background, what would we use? We would put and at the very end of it, so a singular ampersand. If I wanted to replace the contents of a file named passwords with password123, what would be the command? So I would say echo password123 inside of passwords. Very, very simple. Now, if I want to add TryHackMe to that file, but also keep the original, what would we use? Which is the double arrows, I guess we can call them. And that would be echo TryHackMe with the double arrows inside of passwords. And now we have both passwords123 and TryHackMe inside of passwords. And now we can use the deployed machine to put those in practice, which we've already done. I'm not going to do this specific thing because we did so many different examples here already. So you should have an understanding of how to do those commands and how to run those commands. So we can actually move on to our conclusion. Okay, so hopefully this was not too crazy. I know I kind of veered off script a few times, but I was just trying to make sure you really got a good understanding of what was going on. We're going to go over this so many times and over these various basic commands so many times that you're going to get very familiar with them, and it's going to become second nature for you, and you're going to learn how to navigate file systems and create files and append content to files, so on and so forth. You're going to be able to do this like it's nothing. You're going to do it in your sleep, and like my dogs are sleeping in the background. So this was essentially the summary of it, right? So we understood why it's such a commonplace platform, why Linux is such a commonplace operating system. We've actually deployed and interacted with our very first Linux machine. We ran some of the most fundamental commands, such as ls and who am I and echo, so on and so forth. We had an introduction to navigating around the file system using things like cd, right, change directory, and how we can use commands like find and grep to find the data that we need more efficiently. And of course, we have learned about some of the most important operators, for example, chaining multiple commands together using double ampersands, which is actually very useful, because if you know what you're doing, then you can chain the commands and make this super long command instead of writing boom, 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 one after another, especially if you want to have it run in the background, right? You can chain multiple commands together, and at the very end of it, put a single ampersand, and it'll run everything in the background, and then you'll be able to accomplish a lot. So that was it for everything that we talked about, or everything that we did inside of our very first Linux fundamentals room. And now what we're going to do is we're going to go into Linux fundamentals part 2. I also do want to note that this was actually a free room, so if you have just a basic free membership with TryHackMe, you can launch that virtual machine, that Linux machine inside of this room, and run all of the commands. If you don't by any chance have a Linux machine or access to a Linux machine, you can just run it for free inside of this TryHackMe room, which is the Linux Fundamentals Part 1, which was a part of the Cybersecurity 101 pathway. Alright, so if you found this video useful, and if you want to get access to more videos like this one as we go along the CySec 101 pathway, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And of course, drop a comment if you have any questions. I do respond to all the comments. And if you have a really good question or a comment, I'll create a video in response to your comment. So make sure you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And then there is the Hackaholics Anonymous membership community, which is the premier YouTube community for cybersecurity and hacking. And we have 4 tiers with a lot of great perks attached to them. And even the very basic tier, the very first tier that you can get access to for $4.99, you get your own Discord server that's available, that you get access to me and all of our advanced members. So if you have any questions, or if you want to talk to somebody as you go along this journey, you can get access to somebody like that and ask all your questions. And of course, there's the advanced tiers as well, that you get things like Python automations, and you get things like exclusive content and manuals and a bunch of other stuff that there's a lot. The tiers and the perks attached to those tiers go pretty deep. So if you don't want to watch this 14-minute video that's right here, you can just click on this read more button at the bottom, and then you can go through the descriptions, and the description will also list everything that's inside of Hackaholics Anonymous. So if you haven't already checked that out, make sure you check out Hackaholics Anonymous and save it for future if you don't want to join right now, because I promise you this is going to be the biggest group for ethical hacking and pen testing and cybersecurity that exists on YouTube. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next video. Later. Peace. Alright, we are now in part 2 of our Linux Fundamentals series that was a part of the CySec 101, Cybersecurity 101 pathway of TryHackMe. And in the last video, we went through some very basic commands. We went through the history of Linux and just some really basic structures for operators and running commands operating with the file system or navigating the file system. And today we're going to be going through a little bit more advanced stuff. So we're not going through, again, this is still considered a Linux fundamentals video, so we're not going to be going through anything crazy, but we will be going through some basic scripting. We're going to be going through more navigations inside of the file system, and we're even going to talk about SSH, which means secure shell, and secure shelling into the Linux machine to be able to run everything that we need to run. So this is a build up to the Linux Plus certification training series that's going to be coming out in a few weeks. And this is by no means meant to replace anything that happens in the Linux Plus certification. This is mostly to help you kind of familiarize yourself with Linux, so that the Linux Plus certification series will help you pick up where these videos leave off. And I think it'll be an exciting series of weeks that are going to come up, especially for people who are interested in getting more of an advanced skill set in Linux. That being said, our introduction to this particular room essentially says that we're going to unlock the potential of the few commands by using flags and arguments. We're going to go through the advanced knowledge of the file system to be able to do something like copy and move files, which we kind of already talked about in the last video, the fundamentals video, and then how to access files and folders and how access to them is managed, and how we can determine our access and run the first few scripts and executables. So should be pretty exciting, and very much ready to get into it. In the last video that we ran, we actually used the in-browser functionality to access the Linux machine. So we literally, all we had to do was click this green start machine button, and the machine was up and running, and we can run commands inside of the shell, inside of the command line. In this particular case, we need to use secure shell to connect to that machine. So I've already clicked the start machine button, but in this particular case, it didn't open up the terminal that we were looking for. So what you see on the right hand side right here is actually the attack box that comes with Linux, with TryHackMe rooms. So a lot of TryHackMe rooms can get access to the attack box, which is essentially another Ubuntu Linux machine that allows you to run a lot of really cool tools for cybersecurity and pen testing. But it's a Kali Linux machine, and it's something that has a graphic user interface, as you can see right here. And this is not in particular the machine that we're going to be accessing. One of the ways that you can find out which one you're supposed to be accessing is the IP addresses. So we see that the target IP address is the 81164, and the attack box IP address is 112.100. So in many of the rooms inside of TryHackMe, there's going to be a victim machine, or a target machine, so to speak. There's going to be a target machine, and there's going to be the attack box machine. And in this particular case, that's what we have. So what we need to do is we need to secure shell into the target machine. And secure shell is actually very simple. So you just open up your command line, and you run the command SSH, which stands for secure shell. And SSH runs on port 22. This is a little bit networking fundamentals here. So we actually have the breakdown over here as well. So it says it's a common means of connecting to and interacting with command line of a remote Linux machine. While it deploying it, you can will be running these two machines, which we already talked about. And essentially what it does is that our computer, so in this particular case is going to be the attack box, our computer will go through the internet, it'll encrypt our communication, and it'll connect to the Linux server through that encrypted communication and allow us to do what we need to do with the shell, with the command line terminal of that Linux machine. So we can actually execute commands on an entire on another device completely and remotely, and any data that's sent is encrypted, meaning nobody will be able to read what you're doing, right? So if I send my username and password, which is what I'm about to do, right? I have to actually send the username and password to connect to this target machine right here. So once I do that, that should be encrypted, which is very, very important. So in this particular case, the username and password for us is going to be TryHackMe, or at least the username, excuse me, is going to be TryHackMe at the IP address of the target machine, and that's how we run it. And then the password is also TryHackMe. So it's not a very complicated username and password. But the way that that looks, right? So I'm just going to copy this IP address. So we can see that this is the IP address of our attack box machine. So what I'm going to be doing is I'm going to connect to TryHackMe, the user, at this specific IP address, which is the IP address of the target machine, and that's all I want to do. So I'm just going to do SSH to that user at that IP address, press enter, and it's going to say, hey, are you sure you want to do this? We're going to create this encrypted fingerprint. And it's like, yeah, I do want to do that. So I'm going to press yes, and now it's going to ask me for the password of that user, which is going to be TryHackMe as well. And then a couple of seconds later, and I am now officially inside of the command line of that target machine. So you can also tell that it worked by getting the new command line. You can also see that it's listing all of the details of that Linux machine. And usually when it doesn't work, it just says password incorrect. So you'll know that it didn't work, but it officially worked. So it's actually working. And now we're inside of the target Linux machine. All right, so similar to the last video that we had, I'm going to open this up in a full screen format so we can just navigate back and forth much easier between our instructions and the actual machines that we have. And these are the series of commands that we're going to be running and the explanations for them. So I'm going to open this up in a new window. I actually have it opened up inside my second window, inside my second monitor. So I'm just going to use this machine itself, and then we're going to run all of our commands inside of this box and then get the results that we need to get, right? So from the previous video, if you remember, clear will clear our screen for us so we can access all the contents or read the contents much easier. And from here, we're going to be running our series of commands. So the very first command, and this was also a command that we covered in the last video, the command itself is ls, and it lists the items that are inside of your directory. So I always start with figuring out my working directory. So pwd will print your working directory, and I'm inside of the home TryHackMe. The next one is ls. So what is inside of this directory? And then we see these visible files. Now what we want to do, this is one of the options, one of the arguments that we can run to figure out what is hidden inside of this directory. And you run that, and then all of a sudden you see that there's these other these other documents or these other script files. There's some other documents and files that exist inside of our folder, and there's actually also a hidden folder. This .cache is actually another directory that we can go into. Now, if you want to look at it in a much more user-friendly way, you can just add the L, so it kind of turns it into a list format, which just goes vertically, and then now you have each item, and then you also have some extra details about it. So for example, the date of the creation or the date of the last use, the username or the user group that it belongs to, and the permissions that are assigned to each one of these items. So this is actually a much more user-friendly way to view the data that would be shown on our ls command, right? So now we have ls-a, which is one of the parameters or arguments, I guess we can call it, is one of the arguments. I also call it just an option. So it's one of the options that you can run with that individual command. But ls by itself has so many other options that you can access. So the way that we can do that is by doing ls-h, or you can even do --help. Either of those will work. And then you get access to the entire help menu of the command ls. And this actually applies to pretty much every other command that is available as well. And another way that we can do this is by doing the man abbreviation. So clear the screen here. I can do ls man, or man ls technically. So I should say man ls, let's see. So you do man ls instead of ls man, and it gives you again the help menu, and you can go through all of these things, and then you can either scroll down with your mouse, or you can also just do the down arrow on your keyboard, and it'll take you line by line through each one of the items inside of this menu. But the key difference here is that in order for me to get out of this, I need to actually press Q to exit the manual page, and then it'll takes me back to this particular case. Whereas when I did ls-h before, or excuse me, ls help, when I did that, I was already, it just prints everything onto the screen, and at the bottom right here, I already have my command line back, so I don't need to queue, I don't need to quit out of the manual page. I can just clear my screen and everything will be all good. But either one of those two, so ls-help or man ls, will both get you the manual page and the help page for the command ls. And that typically works with all of the other commands that come with inside of Linux anyway. Every command, or every tool, even every tool that you download and install, every package that you download and install, there is usually a manual page that's associated with it, or a help page that's associated with it. Some of the tools have -h being the access that you can get to the help screen. Some of the tools have --help, but both represent the same thing. My favorite way is to just do man for manual and then run the command. So man grep, for example, will give me the manual page for the grep command, right? So this is a very, very useful approach, especially if you haven't worked with a tool before and you just want to know what the options are and what you can run, what are the arguments that you can run, what are the various tests that you can run, so on and so forth. So that's how you access the manual for any given command, or the help screen for any given command. That being said, we have a few questions for this particular section that it basically says, explore the manual page of the ls command. What directional arrow key would you use to navigate the manual page? And you just press down on it. And what flag would you use to display the output in a human readable way? And that would be the -h, which is for help or human. So that is what we can do in that regard. All right, moving on to interacting with our file system. So we've already covered some of these very base ones that we have. We have ls to list the contents of the directory that you're in. You have find, which we ran in the last video, to find any particular file or folder by its name. And then we have cd for changing the directories. And now we have the full list. I mean, I don't think this is actually the full list either, but this is some of the more other commonly used commands that you will run to interact with the file system. So you have touch, which again stands for touch, but what it does is it creates a file. mkdir stands for make directory, and that creates a folder or a directory. cp stands for copy, and it'll copy a file or a folder into a new location. mv stands for move, and it'll do the same thing. It won't copy it, but it'll actually move the file or folder into whatever location you designate. rm stands for remove, and that'll remove a file or a folder. And then we have file, which actually just gives you the type of a file. So sometimes that's also very useful. You need to determine what type of a file you're dealing with, and based on the type, you know how to interact with that file. So one of the pro tips right here, similarly to using cat, we can provide full file paths. So directory 1, directory 2, note for all of these commands, right? So you can say touch and then give a full file path to create that file in that particular pathway. And then same thing with the rest of these things. All of these things can work with a full path to create or remove or copy inside of that given path that you want it to do. So that we have as our list of commands. So now what we can do is we can run these commands and have some fun with this particular directory that we're in, or this machine that we're in. So let us do the very first piece, which is to create a file, right? So to create a file, you just run touch, right? So I already know that let me zoom in a little bit more. I already know that I'm inside of the basic working directory, the home of this TryHackMe user. And I already know that if I run ls, I have these, important, or these mostly used documents, right? Easily accessible documents, I guess I should say. These are the easily accessible documents, and I also have these hidden documents as well. So that's where we are with our specific directory. So this is our current directory. These are the contents of our current directory. So what I want to do now is I want to create a new file, right? So I can say touch note, and now I've created a file. I can do lsl again, and now I see I have a file here, note, right? If I do cat note, there's nothing in it, so nothing is going to print onto the screen for me because it's literally an empty file. Now if I do file note, it'll say it's a note and it's empty, right? So that's essentially how you can determine what type of file you have. Now notice that we didn't assign an extension to it. So if I do touch note.txt, it'll create a note.txt, which is separate from this original note. It didn't replace it. And if I do file note.txt, it'll say note.txt is empty and there's nothing in it, but it gives us that .txt file, right? We can now use make directory to create a new directory, and I'll just call it dir1 for our case, and then we can do lsl, and now we can see we have a directory called dir1. And now the contents of our current directory, our working directory, have changed, and we have these two notes that we have over here, these two files that we created using touch, and then we have this directory. So let's say I want to kind of clean up this current directory that I'm in. I can use move, right? I can use move, and I can use move to move the note file into dir1. And so this is something that we did in our last video. You can kind of chain commands together. I can also use move to move this particular thing into dir1 as well. And now I press enter, and now if I run lsl, we'll see that those two files are gone, but I can now go into the dir1 directory and run ls, and I can see that they're inside of the new directory, right? So you can chain those commands together. So I created a new directory, I created a couple of files, and I moved those files into this new directory that we have over here, which is our dir1 directory, right? So now I'm done using these files that I've created here. I'm done using that note and the note.txt. So I'm going to remove them. So I'm going to do rm to remove, and I'm going to remove note. And then if I do lsl, we'll see that note is gone. We just removed it, right? Very easy, like super easy. There's something called the -r, the $R switch, or the $R option, argument, so on and so forth, that you need to do to remove a directory, right? So if I go back one here, and I'm now inside of this main directory again, and I see that I have that cd, that dir1 directory. So what I want to do is I want to remove that, so I need to do -r and then do dir1. And now that directory is also removed, as well as everything that's inside of that directory. So it literally just deletes the directory and anything that's inside of it. So if you want to remove a directory, you can still use remove, but you can do -r, the $R switch, and it will remove the directory, and then just remove by itself will remove whatever the file name is that you designate after it. So now let's play around with copy and move. So cp and move. So in this particular case, I'm going to create the file again. So I'm going to create a note, and now we have the note that's inside of our current directory. And what we want to do is we want to copy this note for whatever reason. So I can just do cp note. So that's the first option that you give it. You give it the current file, and then you give it the name of the new file. So note 2 would be the new file. And now I should have two of them, right? So I have note, and then I have the contents or the copy of that note, and everything that's inside of it has been now copied, and it's inside of note 2. So let's say I want to now rename note 2 for whatever case. So I can rename it by using the MV. So MV actually moves a file to a new location, but it can also be used to rename the file. So I can do MV note 2, and I can change it to note 3. And now if I do LSL, we'll see that we have the original note, and then the new note has been renamed to note 3. If I created a directory called directory 2, and I wanted to move note 3, I can move it to directory 2. And then, or excuse me, I should just do note 3 and then do directory 2, and then there you go. There's no // required for that. Now that I've done this, if I do LSL, we can see that the original note is still here, and then we need to go into the dir2 to find that we actually have the new file that we created is sitting inside of the new directory that we made, right? So you can use move to move a file, and you can use move to rename a file. Now here's another cool little note for you. So in our original directory we have the note, right? So let's say now I want to create a copy of this note, and I want to move it to dir2, but I don't have a name, right? I can technically just say I want to copy this, and I want to move that copy into dir2, and I want to rename it as note 4, and I press enter, and I go into dir2, and what I'm going to do is I'm going to ls the stuff that's inside of dir2 just to kind of, how is there no file or directory? We literally have dir2 right there. Oh, I'm already inside of dir2. My bad. Whoops. So we'll just do ls, and we're already here. So there you go. So we have moved the file, right? So if I go back one, and let's just clear this up. So now I'm inside of the basic directory that we were at, and we have the note originally inside of here. And then what I did was I used copy to take that note and copy it inside of the dir2 directory. So inside of the dir2 directory, now I have the original note that I copied and I moved in here using MV. But then this piece right here, this one right here, was actually put inside of this directory using CP. So you can use CP to just place it in the location that you want to place it, or if you create it in that same directory, you can just move it using MV. And then once I'm here, I can just do, MV note 4, and I can rename it to note 7, whatever. And then you do that, and then it renames the file for you, right? So CP can copy a file and take it from the current location to a new location, or you can use MV to move it to that location. And then you can also use MV to rename a file without doing any other modifications, so you just rename it, right? So in this particular case, the final command that we have here is the file command that's supposed to just give us some kind of notification about what type of file we're dealing with. So in this case, note 7 is empty, so there's nothing in it. So I can just do hello world. We'll just do this inside of note 7. And now if we do file note 7, we should actually have something, right? So it says it's a text file, right? ASCII, I call it AC. It's an AC text file. Now we can actually get the type of file. If it's empty, it'll just say it's empty. But if you put something in it, then you'll be able to get that it's some kind of a text file. And then same thing would apply if it was a .txt extension at the end of it. So note 7 is the one that we actually just put the documents into it, from what I understand. So let me see, cat note 7. Yeah, that's the one that we put the text into it. So what I'm going to do is I'm just going to change note 3 from note 3 to note 3.txt, right? And so now I have a .txt at the end of it. But if I do file for note 3.txt, it'll still say that it's empty, so there's nothing in it. So if I now echo hello user into that particular file, Then we do file note3.txt, and we will actually get that it's still an ac.text file or ac text file. So the extension itself doesn't necessarily matter of what the file type would be. It's the contents of it, right? So this is what's kind of good to keep in mind for future reference. The contents of the file will determine the file type that you get, not necessarily the extension of the file. So just keep that piece in mind as we progress through the rest of the tasks and the rest of the videos, because that is the ultimate determining factor of what type of file you're dealing with. So we've gone through all of the commands here, and let's go through the question. So it says, how would you create a file named new note? And you just do it by using touch new note. On the deployable machine, what is the file type of unknown one in the TryHackMe's home directory? So let's actually go do that. So we have the home directory that we got to go into, and inside of the home directory we have the unknown one. So I'll just do file unknown one, and then we see that it's an AC text file. Very good. And it says, how would we move the file my file to the directory my folder? And we have that over here. So we've done this multiple times. You would first do mv, you do the file name, and then you give it the location that you want it to move to. What are the contents of this file? So the my file is the content that we're looking for, and this is the file that we have over here. So we can just do cat, so to concatenate that, and we do cat my file, and it gives us the flag, which is thm file system. And to continue to apply the knowledge and practice the commands, no answer needed, and we will definitely continue to apply this knowledge. So moving on to our next task here, which is the permissions. So now let's talk about file permissions. All right, so we've actually gone through a few commands, not in this particular video, but in the last video, where there were some files that we could not get access to, or certain folders that we can't get access to. So permissions are a big deal. And as we go into the Linux Plus certification video, we'll be talking about permissions and security in depth. But it's a concept that you should be very familiar with. And I think just in general, you should be familiar with this concept of, yeah, there are certain files you just don't have access to. There are certain folders you don't have access to. A user will not have access to the files and folders that belong to the administrator because of the permissions that have been set on the administrator's files and folders. So there's a lot of things that permissions covers, right? It's like a big concept. So when we do LSL, which we've ran multiple times, there's this first portion right here for every single line item that actually tells us what the permissions are associated with each one of these files. And what you can see is that there's a dash, there's a R, there's a W, and then a dash, and then a couple of dashes and a couple of dashes. So the dashes are placeholders for the permissions that are not there. And typically, those permissions would be read, write, and execute. And read would be the R, W would be the write, and then X, the letter X, would be the execute permission. So if we switched to a user that actually had those permissions, and in this case we're going to actually do it, we'll run those same commands and we'll see that the file permissions will be updated according to that user's permission level, right? So in the initial screenshot that we had right here, the cmnatic file, right? So that was the original user that was created in this particular case. If we go to user 2, that it has, so it says it has the indicator of the dash highlighting that it's a file, and then the RW followed after this means that only the owner of the file can read and write the cmnatic PEM file, but cannot execute it, right? So the differences between users and groups, briefly, is that permissions can be so granular that while a user technically owns a file, if the permission has been set, then a group of users can also have either the same or different set of permissions to that same exact file without affecting the file owner itself, right? So the permissions of the owner may not necessarily translate to a group that has been designed for, and vice versa, right? we can put this in a real world context. So the system user that runs a web server must have permissions to read and write files for an effective web application. However, companies like the web hosting companies will want to allow their customers to upload their own files for their website without being the web server system user, compromising the security of every other customer. So that means what? That means the web hosting company should allow each of their users to actually be able to upload files and folders into their individual web servers, but the user should not be able to access the web hosting company's files and servers, and vice versa. Because of privacy reasons, the web hosting company should not be able to access the files and folders of each individual user, especially if it's a web server and all of these various types of service-based web servers that you would be using to create customer lists and create your products and services and proprietary information. They should not be able to access it. If you have intellectual property that's hosted on your web server, Google Cloud should not be able to access your intellectual property and then steal your intellectual property and create their own version of it. You know what I mean? That it just shouldn't happen. So it's a very granular, as the word was used. It's a very granular system, meaning that it's nuanced, and the permissions can be very, very specific according to groups and ownership and people creating and uploading files, so on and so forth. So switching between users is done through the su command. Unless you're the root user or using root permissions through sudo, then you're required to know the password of that person, so as well as the username, obviously. So you need to know the user that you want to switch to, and then you need to know the user's password, unless you're the root user. If you're the root user, you can essentially do that change without having the password. The su command takes a couple of switches that may be of relevance. So for example, executing command once you log in or specifying a specific shell to use. We can read the manual page for su to find out more information, but we're going to go through this specific portion right here, which is the L or the login switches. By providing L, we'll start a shell that's more and more similar to the actual user logging into the system. We inherit a lot more of the properties of the new user, for example, the environment variables and everything else. So you do su, and then the user, you give them the password. When we use su to switch to user 2, the new session drops us into the previous user's home directory. So in this particular case, we can see that we're inside of the home user 2 directory. And after that, if we use L to the new, our new session has dropped us into the home directory of the user automatically, right? So if we go here, for example, we can see that in this particular case, this was the user. So I kind of read through that quickly. So let me kind of brief over that. The user here is TryHackMe. The TryHackMe user switched to user 2. While we're signed in to user 2, we're still in the home directory of TryHackMe. However, when you use su and then you use the L option or the L argument, you go from user of TryHackMe into user of user 2, but now you're also inside of the home directory of user 2. So the L option will take you into that specific user's home directory, while just doing su and the username will keep you wherever you were when you ran that command. So on the deployable machine, who's the owner of important? So let's go ahead and check this whole stuff out right here. So on our machine here, what we want to do is we want to find some of the owners and permissions and everything else. So first and foremost, let's look at the ownership of the file important. And so we will do that with lsl, and we got that. And then the important file is used and created by user 2. So what would be the command to switch to that user? And in this particular case, is going to be su user 2, right? The password itself is user 2 as well. So I'm going to do the L flag just to make sure that we actually switch there. The password is user 2. And now we're inside of their home directory like that. So we can clear this up now. So it says the first question was who's the owner of important, and it's user 2. The next question is what would be the command to switch to that user, which is the su user 2. Now switch to them using the password user 2, which we already did. And now we have important, which is the contents of that file itself. So if I do ls There's nothing inside of this thing. So actually, I shouldn't have ran the L command. Notice that, right? Because the contents of that specific directory that we were looking at was not the user2's home folder. It was TryHackMe's home folder. So what we need to do now is we need to navigate backwards and go into the TryHackMe user. And in this case, we now have the important file here. So now I can go ahead and do cat of the important file and get the content of it. So sometimes you don't need to do all this extra things to be fancy because it makes you do more work, just like what happened right now. So you don't have to use the L command when you're doing this switch user, because it will take you to the home folder of that specific user when the file that we needed to access for that final question was technically inside of the home folder of TryHackMe. So that is all of the questions that we have for our permissions portion of this particular room. So let's move into the common directories here. One of the most important directories that you will run across when you go through pen testing and security is the etc directory. The etc directory holds a lot of the commonplace, or we can call it actually configuration files. There is a lot of important configuration files that reside within the etc directory, and as the acronym implies, it stands for etc. And so system files are here, and these are very, very important system files. Two of the most important system files, for example, are going to be the password and the shadow files. Now, contrary to their name, the password file does not store passwords. It stores usernames. The shadow file stores the hashes of all of those users' passwords. So you still won't see plain text passwords inside of the shadow file, but you will at least have the hashes of those passwords. And if you have a decent rainbow table, or if you have a decent tool, you can reverse engineer the hash of that specific password and get the clear text version of the password. If you know how to pass the hash, then you can use pass the hash tactics to use the hash value to log in as a particular user instead of using the clear text version of those passwords. So it's very, very important. These two particular configuration files are very, very important because they store all of our usernames and passwords for that specific system. So if we went inside of the etc folder in this particular case, and if we ran the list command, we can see that the shadow file is here, password file is here. There's a list of all of our sudo users. So these are all the people that have sudo permissions, which is also known as root permissions. And there's the sudoers.d file, which I believe is just a directory or a database type of a file that is associated with that list of sudoers. Then we have the var directory, var, however you want to pronounce it. It stands for variable data. So this is dynamic data, and dynamic data means data that's changing consistently. And one of those things is logs, right? So if we actually go inside of the var directory, we can find a log directory, and inside the log directory, you'll have a bunch of different log files, and those log files are constantly changing because they're always being updated with new log items. And then you can also have an optional directory that's inside of the var directory and a temp folder that's inside of the var directory. These are not to be confused with the actual optional and temp folders that are inside of the root directory. So it would be a /tmp. That would be the actual root portion of the temp files. And these belong to specifically the one that are inside of the var directory. And of course, as you can see, backups are also in here, which would be, you could have regularly scheduled backups that would take place that would also be contained inside of this particular folder. And all of this file falls under variable data, or data that is dynamic and it's being constantly changed, frequently accessed, or written. That's essentially what the purpose of the contents of this particular directory are. And then we have the root directory. So this is not the home directory. So when you go inside of the root folder, so I'll actually show you this because I think it's easier to notice what's going on here. So if we go backwards inside of the root folder, so if I went to the very root. Notice how home has been removed and TryHackMe has been removed, and we only have this / right here. That means we're currently inside of the root directory, and when you do pwd, it literally just gives you that /. Once I do ls, we can see that all of these other important directories are here. One of them is the home directory, and that contains all of the individual home containers for each individual user, right? So if I go inside of the home directory and list it, we can see that we have these various users, and for each one of these various users, there's going to be individual files in here. So you can see that inside of TryHackMe's home directory, there is all this information, and then inside of user 2, we already saw that there was nothing in there. So going back into the root folder, we can see that we have the optional directory in here. That was also one of the things that was inside of the var directory at the end. We also have the temp folder that was also inside of the var directory. We also have the root directory that we just talked about right here, and that was a really important one as well. So if we go inside of root, we can see that there's been denied permission here. So if I try to do cd with, do sudo, so if I do sudo cd root, I'll be asked for a permission or a password for that, and if user 2 is not in the sudoers file, this will be reported to whoever the system administrator is, because we're trying to access the root folder without actually being somebody on the sudoers file inside of the home or inside of the root or the sudoers list, right? So if I switch back to TryHackMe, then I will have to provide TryHackMe's password, and I'm now here, and I'm now back again inside of this particular root folder as well. So if I try to now change into the root directory, I don't know if TryHackMe he doesn't have access to that either. So TryHackMe user is not in the sudoers file either, and that has now also been reported to the system administrator, right? So the root folder is a very important folder, because it is not the home folder for the root, or it's not similar to the home folder in any way where you can access whatever user information in there. It is only accessible by somebody who's either in the sudoers file or is the actual root user, the main user. So it's very important to understand, right? So this is not the same. This is not the home directory. The root folder is actually the home for the root system user. There isn't anything more to this folder other than just understanding that this is the home of the root user. But it is worth to mention, because the logical presumption is that this user would have their data in a directory such as home root by default, right? They get their very own directory inside of the root folder. We have the temp directory. So it's a unique root directory found on our Linux install. It's for temporary files, and it's volatile, and it's used to store data that is only needed to be accessed once or twice. Typically, it gets wiped every time the system is restarted. So similar to the memory on your computer, once the computer is restarted, the contents are cleared out. What's useful for us in pen testing is that any user can write to this folder by default. So keep that in mind, right? Most of the pen testing exercises that we've ever done on this particular channel have had to do with the temp folder, because even the lowest user with no privileges can access that temp folder and write something in there, right? Meaning once we have access to a machine, it serves as a good place to store things like enumeration scripts, because we can actually write into this, and then in there you can have a number of items that will most likely you'll be able to run and write to, simply because of the fact that it's the temporary folder. So it's a very important one. And then when you look at it from the perspective of a system administrator or security officer, that's something to be aware of, that if somebody gets into your system, they can run stuff from the temp folder. So the temp folder should be watched closely, and it's a very important folder. The questions here. So what is the directory path that we would expect logs to be stored in, which is inside of the variable directory, and we have the log directory, and it has all of the log files. So let's actually go in here. Let's see if we can access it. So if I go into var, we have the log file right here. That's over here, and I should be able to see, cd log, and we are actually inside of it, and now we can see all of the log files that are over here. So there's the authentication log, and then there's the depackaging log, there's the sys log, and a variety of other logs that are also very important. So let's see. Next question. What root directory is similar to how RAM on a computer works because it gets wiped? So random access memory gets wiped on reboot, and that is very similar to the TMP, the temporary directory. Name the home directory for the root user, which we already know is the root directory. And now we can navigate through these directories on the Linux machine, which we've done already. So feel free to do the same thing for yourself and have some fun with it. So let's go into the conclusion here. All right, so what we have covered in this particular room, we learned how to secure shell into a Linux machine and using the basic SSH command. That was very, very easy. Advancing your use of commands by providing flag switches and where you can go to learn about these things. For example, the manual page or the help page for each one of those commands. Some more commands that you'll frequently be using to interact with the file system. For example, finding the hidden files or listing items inside of any given directory, cleanly looking at the permissions of those particular files or the users that created those files. All of those can be done with the same exact command, which is LSL, with the ls with the -l option. A brief introduction to file permissions and switching users, which we did beautifully, and summary paragraph of the important root directories on an Ubuntu install and how we may be able to use the data stored within those. And that was everything that we found inside of this root directory right here that gives us access to all of these other directories here, which could be the user directory. You have the binaries directory. There is the system binaries directory, the sbin directory. So all of these things are very, very important directories. We'll be covering these in depth as we go into the Linux Plus certification course that is going to be coming up in the upcoming weeks. So it's going to be pretty exciting to go through. And we have one more video left, or one room left, for the Linux fundamentals, which is going to be Linux Fundamentals Part 3. And to be updated so that you can get access to that particular video as it drops, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, especially on this Cybersecurity 101 pathway that we're on. And there's a lot of stuff that is going to be dropped because that's actually a big pathway because it covers a lot of fundamentals and a lot of information that is important to people who are just starting out. So that's the main reason why we started this particular CySec 101 pathway. And there's going to be other advanced videos that are going to come out as well. For example, everything that we're doing for SOC Level 1 exercises, and then continuing on to SOC Level 2. And then, of course, the Linux Plus certification for CompTIA. That massive video that's going to come out is going to be massive freaking video. It's probably going to be 2 videos because the maximum upload time is 12 hours on a tutorial. So if I can cram it into one giant video that's less than 12 hours, I'll probably try to do that. But I think it's going to end up being more than 12 hours. So it's going to be a 2-parter. And it's going to be a really, really, really powerful, useful video because we're going to go in depth into Linux. So if you aren't familiar with it, this is why we're doing the Linux Fundamental series right now, so that when you go into that video, you'll at least have a good understanding of the basics. So make sure that you like, subscribe, and turn on the notification bell so that you get notified that when that video comes out. And of course, drop a comment, if you have anything to say, if you want to show appreciation, if you just want to say hi, if you have any questions, drop a comment and let me know what's up. I do respond to all of the comments that come in, and if it's a really good question, I will create a video in response to your question and you will get a shout out, just like Darnell Knight has gotten a shout out pretty much for every video that's come out for the CySec 101 series, because he was the reason why I started the CySec 101 series. So yeah, definitely let me know. And that's about it. That's all I got for those specific announcements. I do have to give a shout out to the Hackaholics Anonymous community, the #1, the premier community for cybersecurity and hacking. And this is actually something that I'm very, very excited about. Our members are amazing people. We have 4 tiers. Even the most basic tier, which is the supporter tier, gets their own Discord channel from now on. And you get access to me individually. You can ask me whatever questions you want. You get access to all of our advanced members as well. So you can drop a question in there, and people are very responsive. They're very, very supportive. And it's one of those things that if you're going along this journey and you want somebody to be there with you along this journey, that would be a great place to be. And if you have all these questions that you may not necessarily want to drop them in the comment section, that's a great place to be. If you want to join the advanced tiers, for example, cyber agents and cyber supporters and cyber masters, if you want to join any of those, you will get Python automations every single month. You get exclusive downloads, exclusive content. There's individual systems or servers, for Discord that is assigned to those people. So there's a lot of great information that is available to those particular individuals, and a lot of great perks that are available to every single one of the tiers that we have. So if you haven't checked it out already, I do encourage you to check out the Hackaholics Anonymous membership community, the premier YouTube community for cybersecurity and hacking. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I'll see you in the next video later. Peace. Alright, and welcome to the third part in the Linux Fundamentals series for the CySec 101 pathway. And this is going to be our last fundamentals video for Linux. There's other videos that are going to be coming up for Linux Plus certification, so on and so forth. And in this one, we're just going to be going through some text editors and general useful utilities, processes 101, maintaining system automation, maintaining the package management, and of course system logs. So it's going to be a fun one. It's going to go over the rest of the fundamental concepts so that you understand how Linux works. And from there, you should be primed and ready to go to jump into the Linux Plus certification video that will be launched in a week or two. So I'm excited about this one, and let's jump into it. Okay, so we learned about Secure Shell in the very last video, so the Linux Fundamentals Part 2, Linux Basics Part 2 is probably how it's going to be named. And we learned how we are supposed to use the attack box that we got to secure shell into it. Now, if you want to use your own computer to secure shell into it, you're more than welcome to. You got to connect to the OpenVPN server or the configuration file that is available through TryHackMe to be able to connect to all of their virtual machines in this regard. But if you're using the attack box and just the TryHackMe service by itself, once you click the start machine, you get the IP address that populates at the very, very top right here. And the command is very simple, right? So you do SSH, TryHackMe, add that specific IP address, and then this is the password. So the username is TryHackMe. So let me just show you. It's probably easier to do it this way. So we're just going to run SSH, TryHackMe at the IP address, which is that. You press enter, it asks you, hey, do you want to do this? It's going to create a SHA-256 hash for the fingerprint, and I say, yes, I do want to do this. And then now I'm going to provide the password, which is TryHackMe. Takes a couple of seconds, and then we are inside of the Linux machine that we're supposed to be connected to. So I'm going to run clear to clear up the terminal, and that's basically it. You're logged in. We're logged in as TryHackMe Linux 3 because it is part 3 of the Linux Fundamentals video. So now that we're in here, let's actually go into the terminal text editors here. All right, in the last couple of videos, we actually went over how to use the echo command to pipe information, or essentially input or send information into a text file by using a single greater than sign or the double greater than sign. And this is an efficient way to handle data when you're working with a lot of files, and if you want to just dump a bunch of data inside of a file. So you could technically take the output of any command and dump it inside of a file using these specific operators. So once that data is inside of a file, you need a terminal text editor. And my favorite is Nano, but Vim is also very, very popular, and a lot of people use it. And there's actually rooms that are dedicated to these things. So we're not going to go into the depth of what these things are and how they work and the various options that come with them, but you should be able to actually work with them and navigate what they do. So in this case, inside of the temp directory, there was a my file, and they did nano my file, and it opens it up, and this is what it looks like, right? These are the contents of contents, of my file, which is basically, that's it, right? All these options that you see right here show up at the bottom of any individual nano computer, or nano, not computer, excuse me, text editor. So if I am inside of the Linux machine, I do print working directory, and I do an ls, and I see that there is a task3. And if I do try to go into it, it's actually not a directory. So I know I can do nano task3, and it'll open up what's inside of task3. And it says THM text editor. That looks like a flag, and we're probably going to use it later on in this particular task that we're in, right? So THM text editor, and then we have all the options at the bottom right here. These are the options that I was just talking about. And these individual options could be, you know, where is right here. I use this a lot because I'm trying to search for a specific string or email address or a pattern, anything like that. You use where is. It's basically find. You can find something inside of the individual file that you're in. When you do Control O, and that's what that upward arrow is control. Even on Linux machines or even on Mac OS machines, it's control, it's not command, right? So Control O would write it out, and then it'd say, are you sure you want to write it out? And I say, yes, I want to write it out. So let's actually do it, right? I'll just do modification, right? That would be my new text. And then I have to do Control O, and it says file name to write. You have to press enter to actually write it, and you say, okay, cool, you wrote 2 lines. And I do Control X to exit, and now I've exited. So if I run the cat task3 command, now I have the modification that I added using the text editor, right? And that way you can add a bunch of lines of text or even write scripts inside of a file by using nano, right? So that's what nano essentially does, and it's a very, very useful text editor. And if I don't have a file already, instead of using touch to create the file, what I can do is I can use nano to create the file, and it'll open the file as soon as I've created it. So I can do nano my file, and then just open a file for me, and then now I can write whatever I need to inside of the file, and then go ahead, and if I want to exit out, so instead of doing Control O to write and then pressing enter, if I just did Control X to exit it, at the bottom it says, hey, do you want to save this? And I can say, yes, I want to save it. And then that's it. Now I can exit out, and I can do cat my file, and it'll show me all the jargon that I just typed into it, right? So nano can actually even create a file for you. And then we can go and you know, this is what we've done right here. So we already did all of that. So write and create. So we're actually way ahead of the game here. The next one is Vim. It's a much more advanced text editor. You're not expected to know all the advanced features. It's helpful to mention how you can power it up and how you can exit, right? So we can go here and we can do the various pieces. I mean, there's actually no other commands that they've given us to run. They just told us how to power it up and how to exit out of it. But some of the benefits here include that it's customizable. You can modify keyboard shortcuts. There's highlighting of the syntax. So if you're writing or maintaining code, you can actually see various color coding and highlighters. That makes it just easier. It works on all terminals where nano may not actually be installed. And there are a lot of resources such as cheat sheets, tutorials, and everything that's available for Vim. And same thing is available for nano as well. So it's not to imply that all these things don't exist for nano. As far as cheat sheets and tutorials and things are concerned, there's a room that showcases Vim that I actually have not gone through. So I will probably do that at a later point. Let me just open it on a different tab so I don't forget it. So, okay, so let's just open up Vim real quick and see what we can do here. All right, so we have a new file. So let's say we're going to do vim file.txt in this particular case. And now, there we go. We got an empty file using Vim, right? And I can go ahead and essentially just do, what is this? Colon. So not semicolon, colon, and Q is how you would exit out of this. So it's at the very, very bottom right here that you can see. So colon, Q, and then you press enter, and it exits out of it, right? So that is essentially how you interact with Vim, and you can essentially just do Vim, the file name, and it'll open it up. And in this particular case, it didn't create a file for us because it was just an empty file and we didn't do anything to save anything from it. So that was essentially just kind of just how to open it and how to close it. If I just did vim by itself, it'll give you a few helpful commands at the very beginning. So for example, type :Q to enter, or to exit, excuse me. So :Q and then press enter and it'll exit. If you do :help, enter, or F1 if you have a keyboard that has that, it'll give you a one-line help menu. And if you do :help and just press enter, or excuse me, :help space version 8, press enter, it'll give you the version info. And then of course there's the actual help menu itself. If you do :help sponsor, it'll give you the information itself. If you just do :help enter, it'll give you the help menu. So this is it's very, very basic. We're not going to be going through anything fancy with this particular tool. You just need to know that it exists, and there are two text editors. My default is Nano. I just go through Nano because it's more, I don't know, I think I've just used it so frequently that I'm more comfortable using Nano. But you have access to both of them. You have Nano and Vim that's available. So right here, it just says create a file using Nano, and we've done twice actually. And then edit task 3 located in TryHackMe using Nano. What's the flag? And we already got that one as well. So we were a little bit ahead of the game for that particular question. So let us talk about these other utilities here. If you want to download files, you can use the wget command. And it's a fundamental feature of computing, especially in Linux, right? So if you want to transfer files or download files, you can use the wget command. What you need to do is give the full URL of where that file is sitting, including the file name at the very, very end of it. So if you do wget https yada 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 yada, and then make sure you have the full thing, it'll download myfile.txt into whatever directory you're actually in. So I'm just going to run this because I do want to see if there's actually a file over there. So I'm just going to copy this particular command. I'm going to go here and I'm going to paste that command, and I'm going to press enter, and it says connecting to etc, etc. And let's see if it's actually going to complete the download. Okay, I waited for literally like 5 minutes at the very least, and I even tried to remove the my file that was already inside of our directory just in case it was having a problem rewriting over it, and it still did not download. So that particular asset is not being downloaded, unfortunately. However, maybe it doesn't even exist. Maybe this is just something that they put over here just to demonstrate the command, but I have used wget before to download things previously, so I know that it does work. It's just in this particular case, it didn't download this particular file for us. You can also transfer files. So in this particular case, we're transferring from our host into another location, and it is very similar to running SSH. It's called SCP, which stands for Secure Copy. And it's literally securely copying files or transferring files from one location to another. So this command allows you to transfer files between two computers using the SSH protocol, meaning on port 22, to provide both authentication and encryption. Working on a model of source and destination, it allows you to copy files and directories from your current system to a remote system, copy files and directories from a remote system to your current system. You can do both of those things. Provided that you know the username and the password for a user on the current system and on the remote system. For example, if you want to copy an example file from the machine to a remote machine, which they have neatly laid out in the table below. So the IP address of the remote system would be this. The user on the remote system is Ubuntu. The name of the file is important.txt. And then the name of the file that would be transferred, because you do have to provide that as well, is transferred.txt. So this is what the full command will look like. You have SCP, the original file, important.txt, being transferred to this person, right? So Ubuntu at this IP address, colon, and then the path that you want it to be transferred into. So this part is very, very important, right? You need to actually provide the path as well as the file name that you need to that you want it to be transferred into. So if you wanted to reverse this process. So this is us transferring the document from where we are to this other person. And once you press enter on this command, you're going to be prompted for Ubuntu's password on this IP address. So just keep that in mind. We're not seeing that, but you're going to be prompted for that person's password to be able to actually transfer files into their computer, right? So if we want to reverse this and get the syntax for using SCP to copy a file from this place into our local machine, this is what we would do, right? So the name of the file on the remote system and what we want to have it look like on our system. So we're going to do SCP, and instead of putting this first, we're going to put this first. So you do SCP, Ubuntu, etc., the location of that file, which again also is a big requirement, is that you need to know exactly where that file is sitting on their computer to be able to transfer it. If you don't know, then it's not gonna search for the file for you and try to find it conveniently. You need to know exactly where that file is sitting, and then you press notes.txt, which is the location on your current directory, wherever you're logged in, and whatever your current whatever your working directory is, that's where this is going to be saved to. And that's it. Once you press enter, again, it's going to ask you what's the password for this particular user. Once you enter the proper password, then it's going to transfer the file for you. You can serve files from your host, meaning you can turn your computer into a server so somebody can go and download the file from wherever it's located using wget or curl, right? It's actually something that we've used a lot to transfer shells, shell scripts that we created on our computer, or Metasploit payloads that we created using MSF Venom on our computer. We transfer it to the target machine using the Python 3 server. And this is actually very, very easy to do, very simple to do. You just do Python 3-m HTTP server. If you don't designate a port number, it'll just choose the basic default port number and it'll tell you what it is. So let's actually do it here so you can see what it looks like. So I'm actually currently logged into the TryHackMe Linux computer. So I'm going to open up a new shell that's going to show me logged in as my specific user, which is root, right? So if I do Python 3-m HTTP server, press enter, and it says it's serving on port 8000, which means the IP address that we have, :8000, which is what? It's this IP address, 10.10.112.100. So if somebody wanted to download this, if I wanted to download the file that's on this current directory from this directory, if I wanted to use it using this server to download a file that's on this machine to this machine, I would need to go to 10.10.112.100:8000. That's where that's what the URL would be, and then / the name of the file, assuming that it's just sitting in the current directory that it's in. So now I just do Control-C and I close out that server that I've created, and it's gone. So what you can do, again, this is what it looks like, right? So you've created the port 8000 server on your specific machine that you have, and then so you would use wget, the IP address, followed by the port, and then my file, and now it will download it onto the machine that you're on, right? Pretty interesting stuff, like easy. It's fairly easy when you think about it. So I'm going to try to see. So what do I have? I have the task3 file is the only thing that I have here, and it's sitting on the home TryHackMe directory. So I'm going to try to do Python 3-m HTTP server. Let me see if this actually has it. It does have it. So now I can download this file, the task3 file, from this particular location on my machine. So I need the IP address of that target machine, which is this IP address right here. And I already know that the username and password is TryHackMe. So I can go ahead and do wget, and I will do HTTP, and I will paste the IP address, and I will do port 8000 and / this is the important part right here, home TryHackMe task3. So I'm just going to do home TryHackMe / task3, enter. and it says file not found. So let me see, home, TryHackMe, task 3. I feel like that's exactly where it would be, right? So on port 8000 of this particular location. So let's see, maybe I did, because the connection was right, the request was fine, but the file itself was not found. And this is actually saying that somebody is trying to access this particular file, but we gave a 404 error, so file was not found. So I'm just going to run the command one more time, and instead of doing home, TryHackMe, etc., etc., let's make sure that we're actually running the correct command as well in this particular case. So they did this, my file, yeah, so that's fine. So in this particular case, what I'm just going to do is I'm going to delete all of this preceding stuff, and I'm just going to do task 3. There we go, and it actually worked. So because I served this particular piece from this directory, I didn't need to do this as a prefix. I just needed to just type task 3, and it actually worked. And now if I run ls on this machine, I can see that I have that task 3 file, and I can even concatenate it onto the screen and have the contents of it printed. So that's very, 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 very useful. Believe it or not, you're going to use this a lot. So Python 3 -m HTTP server, and very, very useful information, and you'll probably use this a lot. So this is what it looked like when we were able to actually download the file, and this is what some of the screenshots look like when you run and download it. So that is it. So to start a web server in the home directory of the TryHackMe user, download the file flag.txt on the attack box. Remember, you'll need to do this in a new terminal and get that flag. So apparently there's actually a flag that is on that computer. So I'm going to just do this because I already have that connection, and I'm just going to do .flag, right? That's what it is, .flag.txt, and download that. There we go. And now we should have a, whoops, I should have a flag dot, where is it? It should be a secret file. Where's my secret file? There we go. So .flag.txt. So now I need to concatenate that onto my screen, and it's very important to put that initial dot at the beginning of it as well, because it is a hidden file. Press enter, and now we have thm wget web server, which is the flag that we got right here. So very, very cool. So now we have Control C to stop the server, and we'll just do that, and we have exited our server. And now we can move on to Processes 101. Processes are the program that are running on your machine. They're managed by the kernel. They are running behind the scenes. More often than not, you will not really see them because they're just running, right? They're managed by the kernel. They have an ID associated. It's referred to as the PID. And the PID increments for the order in which the process starts. So for example, the 60th process will have a PID of 60 because it started at the 60th position, right? It was the 60th process to start. Viewing processes can be as simple as running the PS command. So you provide a list of running processes as the user session and some additional information like the status code of it, the session that it's running in, and how much time or how much usage time of the CPU it's actually using. The name of the actual program or command that's also being executed is also there. So for example, PS in this case will show us a PID of 204 for the PS process that's running, right? 205 in this particular case will show us again because they ran it again. So now it's been incremented by 1, right? And it gives you the name of it as well as the PID itself, how much time it's using, and in this case it's not because it's not a big process that's running. So in the screenshot above, the second process has a PID of 204, and then in the command below it, it has incremented to 205. If we want to see processes run by other users that don't run from a session, we need to provide the aux to the PS command like this, PS aux in this case, and it'll show all the other users that are also running processes and what their processes are, what the start time is, how much of it is actually using, so on and so forth, and the command that are running in this particular case, which we can see as well. So we see a total of 5 processes now, and we have root and cmnatic, which are the users. So another helpful command is the top command. So it gives you real-time statistics about the processes that are running on the system instead of just a one-time view. So it actually updates in real time. And these statistics will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse the various rows. Another great command to gain insight is the top command. So this is what it looks like. You run top, you just press top and you press enter, and it shows you what all the users are, and this will change every 10 seconds based on the CPU usage and a variety of other items or variables that are associated with each of these processes that are running. And it's also something that's very important to check just to see what's going on with the CPU usage of the computer in real time, to see if there's any specific process that's taking up more information that it should, or more data than it should, or if there's a process that just jumped on that shouldn't have, and a lot of other things that it's beyond the scope of this particular video, but it shows you a lot of great detailed information about the processes. So let's say you have a process that you want to terminate. So you can use the word kill, right? This is probably one of my favorite commands just because of the name. There are a variety of types of signals that correlate to exactly how cleanly that process is running and it's being dealt by the kernel. To kill a command, we can just say kill 1337, and 1337 is the PID that's associated with it. So you just say kill, and then you provide the PID, and it'll just kill it. It'll just stop it from running. The signals that we can send to process when it is killed is sigterm, so kill the process but allow it to do some cleanup tasks beforehand. Sigkill, kill the process, no cleanup after the fact. And sigstop, to stop or suspend a process. So you can say kill sigstop, or just say kill 1337. And kill 1337, it just shuts it down immediately, right? How do processes start? This is a very complex topic, so we're going to do an overview here. So first we need to understand what a namespace is. The operating system uses namespaces to ultimately split up the resources available on the computer. So for example, the CPU, the RAM, and the priority of that process. And you can think of it as splitting the computer into slices, like a cake. So processes within that slice will have access to a certain amount of computing power. It'll be a small portion of what the overall computer can do, right? So if you have 10 gigabytes of RAM, you've taken a 1 gigabyte slice, and that process or those series of processes have a maximum of 1 gigabyte to use, right? Namespaces are great for security because it's a way to isolate something, and only those processes that are in the same namespace will be able to see each other. And if there's something wrong with them, they stay within that namespace. It's just an easier way to manage them if anything happens. So we previously talked about what PIDs are and how they work, and this is where it actually comes into play. So the process with an ID of 0 is a process that started when the system booted. So the very first thing. This is the system's init, right? The initiation on Ubuntu, such as systemd, which is one of the system initiation processes, is the most recent one. There's sysvinit, sysvinit, which is kind of the older initiation software initiator, which use and these things provide a way of managing the user's processes, and they sit between the OS and the user, right? So once the system boots and it initializes, systemd is the first process that are started. Any program or piece of software that we want to start will known as a child process of systemd. So systemd will be the parent process, and it will have a PID, which is the parent process ID, and everything under systemd will be its children, its child process. They'll have their own PIDs, but they can also be parent of other processes, of sub-processes. So what it means is that everything is controlled by systemd because it is the very first one. But it's going to run as its own process, also sharing resources from systemd to make it easier for us to identify, and so on and so forth. So the very first one right here, see that's a PID of 1, not PID of 0, is systemd. It's the very, very first one, and it's the user that belongs to it, obviously, is the root user. So if you want something to start on boot, meaning as soon as the computer is started, as soon as the machine is started, we need to actually schedule it or configure that process to run on boot. So for example, some applications can be started on the system that we own, web servers, data servers, or file transfer servers. The software is often critical and is often told to start doing the boot up of the system by administrators. In this example, we're going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. So we enter systemctl, which I believe stands for system control. This allows us to interact with the systemd process daemon. So what it does is that it's an easy to use command that takes the following formatting: systemctl, the option that you want to do, for example, start, and then the service name. So you say systemctl start Apache 2, right? Same thing, systemctl stop Apache 2. Systemctl enable Apache 2. Enable usually comes before start, right? So you can't say start if it hasn't been enabled. So you would say systemctl enable Apache 2 and then start Apache 2. Then you would stop Apache 2 and then disable Apache 2, right? So that's the order of these things. It's kind of not in the proper order here, but that's, if you kind of think about it logically or commonsensically, you can come to that conclusion yourself. So it seems simple, right? So if we wanted to stop Apache, so on and so forth, same thing. These are the commands that we run. And then there's backgrounding. So these are, again, just very, 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 very high altitude overviews of these concepts. We're not going into the depths of these concepts here. I just need you to understand this is how Linux works. So you just have the basic understanding of the Linux operating system so that when we go into more advanced videos, you can understand how all of that works. So backgrounding and foregrounding processes is also very useful, right? Especially if you are only dealing with the command line and you don't have a graphic user interface like what you see here. You only have the command lines, which is what you can see inside of these terminals. So a process can run in two states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo or anything of that sort, are running in the foreground of the terminal because it's just providing you the information right onto the screen, and you haven't told it to run in the background. That's the other piece. So echo is a great example because the output of echo will return to you in the foreground, but it wouldn't be in the background because it's literally on the screen, so it's in the foreground. If you did the ampersand, which is what we talked about in the last video of backgrounding a process, if you did echo hi thm and then you did the ampersand at the end of it, you get this notification, and then this piece right here is the TID, right? Or excuse me, the PID, right? So this is the example, the description here. We're doing hi thm excuse me we're doing echo hi thm, where we expect the output to be returned to us like it is at the start. But after adding the ampersand operator, we're instead just giving the ID of the echo process rather than the actual output as it's running in the background. So this is a great command for copying files because it means that we can run the command in the background and continue on with whatever we need to also execute. And once it's done, you can refer back to it or bring it into the foreground. So we can do the exact same when executing things like scripts. So other than relying on the operator, we can use Control-Z on the keyboard to background the process. It's also an effective way of pausing the execution of a script to see what else you can do, right? So this is going to keep going until I stop it. This is basically the loop that they have. And it's probably, while true, print this onto the screen. That's basically what the script is doing. Until you do Control-Z in this case. And then it's just now in the background, right? And then you can either continue on with it or bring it into the foreground, or you could just kill it. So this script is going to keep repeating until I stop or suspend the process by doing Control-Z as indicated by this piece right there. Now the terminal is no longer filled up with the messages until we foreground it, which we will discuss below. So all of this is backgrounding, as you've already seen. So this is something that ampersand would be something that you add to the end of a command on the actual command line. The Control-Z is something that you would add to a script that's running. So you run the script, it's doing whatever it's doing, it's taking up space inside of your terminal, and then you do Control-Z and it becomes a backgrounded script. So for example, in this case, we had the Python server, and the Python server was taking up space on our terminal here. So instead of doing Control-C, which is what I did right here, I could do Control-Z. So Control-C killed it, right? It killed the server. I could have just done Control Z, and then it would have backgrounded the server, but it would have still been running, right? It would have still been working, and then anybody could have accessed that server to get information if they needed to. So foregrounding the process is where we go back to our process list. So now we have the process running in the background, for example, the background.sh, right? Which we can be confirmed by running the ps aux command and then backpedal using it back to the foreground. So right here is where you see the list. So let me see, maybe I can. So you can see it. So root has this 19802 PID that's associated with it, and it belongs to the background.sh, right? So while the process is in the background, with the process using in the background with Control Z or the ampersand operator, you can foreground it. You can do FG to bring it back to focus. So you also need the PID for this, however, right? So we can just do FG, and then where we output this script now into the foreground, and then you can see that it's running as well. So if we were to launch a process with the previous ID was 300, what would be the ID of the new process? Because it increments by 1 with each time that it runs, so it would be 301. If we wanted to cleanly kill a process, what would we do? We would do sigterm for sig terminate, and you would combine that with the PID. Locate the process that's running on the deployed instance. In this particular case, what flag is given? So let's actually see if we can go ahead and find that. So the process that's running on the deployed instance, which is 190.79, which is our, it's our target machine right here. So we want to find this particular flag right here. So let's go and try to find this particular process. So let me run ps here. And I did ps aux, and it's right here. Actually, you can see it right there, THM processes. And if we just kind of expand on this a little bit, let me make sure I kind of bring this out into the open. And that's what it is. THM processes is the process that's running, and then we have all these other processes that are also running. So I just ran ps aux because I wanted to see the full list of processes that are running. However, if I did ps, I wonder if that would also show. And it does. It does also show. So actually, no, it doesn't. I'm sorry. It doesn't, because this is the list that only shows for the specific series of processes that are associated with TryHackMe user, not the full list of processes that belongs to the root user, for example, which is where this thing belongs to as well. It's a root user process. So we did ps aux, ps space aux, and we were able to find THM processes. So what command would we use to stop the service my service? We would be systemctl stop my service. Very simple. What command would you use to start the same service from at the boot up systemctl enable my service, right? And what command would you use to bring a previously backgrounded process back to the foreground? And that would be FG for foreground. BG goes into the background. Control Z if it's a running script, and then you can just do ampersand at the very end of your command if you're executing the command in the terminal, and it would send it into the background, and then foreground would be FG, and it brings it into the foreground. Automation is one of the most important concepts in system administration, mostly because of the fact that there's going to be a lot of repetitive things that you're going to need to do. And if you don't know how to automate, it's going to take up all of your time and energy. So there's a reason why scripting exists. So let's actually make sure that we don't run out of time here with our virtual machine, which is our attack box. All right. In the case of automation, there are a few things that you should just be very, very aware of. There is something called the cron process, but specifically the cron tabs, which is the list of scheduled processes that start during boot, and it's responsible for facilitating and managing cron jobs. So cron jobs, chronological, I believe is what that stands for. So if you look at the tmp cron tab directory and look at the cron tab file, this is what it looks like right here. So edit this file to introduce tasks to be run by cron. To define the time that you can provide for these things, you can look at the minute, hour, day of the month, month itself, day of the week, so on and so forth. or use the asterisk in these fields for any to just make it run at all times. And the task will be started based on the cron system's daemon notion of time and time zones, so you need to also be aware of that. A cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. They require 6 specific values: the minute, hour, date of month, month itself, date of week, and then the command itself that you want to be executing. When you look at it, this is what it looks like on a line item in this particular case, right? So backing up files, for example, is what we're going to be looking at. So we want to back up CMNatics documents every 12 hours. So we would do the following formatting. So an interesting feature is that they also support wildcard characters, which is what these pieces right here represent, right? So you want to do it every 12 hours, which is what the first part would just be any day, and then 12 hours, right? So if we don't wish to provide a value for that, we can just use the asterisk, which represents everything else right here: day of the month, month itself, day of the week. All of those things are asterisks, which means any, essentially, any day of the month, any month itself, repetitively, perpetually, until you remove it from your list of cron jobs. So this can be confusing to begin with, which is why there are some great resources such as the cron tab generator that asks you or that allows you to use a friendly application to generate your formatting for you, like the cron guru itself. So you can do an editing of the cron tabs by doing cron tab E, where you can select an editor such as Nano to edit the tab itself. And this is essentially what it kind of looks like when you're using one of these helpful tools right here. So if I went over here, the cron tab generator, this is what it looks like, right? So nothing crazy, nothing fancy, but just a couple of point and click that you say that you want it to run every minute, or even minutes, odd minutes, every 5 minutes, every 30 minutes, so on and so forth. Or you can just say however many number of minutes. That's what this piece right here is for, right? So I can do every 9 minutes, every 10 minutes. Let me see if I can drag this down. I should be able to drag that down. Doesn't seem like it's allowing me to. Every hour, day of the month, right? Days of the week, every month, so on and so forth, right? So it actually allows you to do a customization. And at the very bottom right here, it'll give you the command to actually run. Or excuse me, this is where you input the command to run, and then you create the cron tab line, and then it'll give you a formatted version that, oops, let me make sure I close this one. It'll give you the formatted version that will look like this, that you can actually add into the document, the configuration document for cron tabs, right? So we're deployed to the instant right here. When will the cron tab at the deployed instant 10.10.1.90.79 run? So when will the cron tab on the deployed instance run? The answer is reboot, but let's go find it. So we're looking for the specific file on cron tabs here. So this thing shrunk completely. That's pretty amazing stuff. So on this particular machine, we are looking for the cron tab. That would be at our, I think it was at the temp folder. Yeah, TMP cron tab. So let's go to the temp folder. Okay, so I don't think it's actually the TMP folder. That's my bad. I believe what we need to do is run the cron tab E potentially. So let's see if that actually works for us. Yep, there it is. So there is the actual cron jobs or cron tab configuration file. So we're going to go to the very, very bottom. There's only one specific process that's been automated for us, which is reboot. So at reboot, or excuse me, it's been at reboot where it runs this specific process, which is the processes.sh shell file. And you can assign a reboot to be your timing parameter, so that every time you just restart the computer, it'll run it, and that would be the very first process that runs. So very simple, very easy. Hopefully it's easy for you to understand as well. So let's move on to maintaining the system with package managers. When developers develop software and they want to submit it to the community, they'll submit it to the apt repository, or apt is what I refer to it as. If it's been approved, their programs and tools will be released into the wild, right? Meaning it's accessible by everybody. Two of the features of Linux that are amazing here is the user accessibility and the merit of open source tools, right? So if it's actually been approved, then it gets added to the full repo for people to just download and install at their leisure. So when using the ls command on Ubuntu, these files serve as our gateway registry right here. So if you go into the etc apt folder, you can see that these are the configuration files that are listed here for the packages that can run and can be installed. So if you look at the sources.list, for example, this is where the various locations that we can pull our repositories from can actually work. So there's the Bionic Security and the Bionic Security Universe and Bionic Security Multiverse, and then there's an individual URL that goes to those specific places, right? So while OS vendors will maintain their own repositories, you can also add community repositories to the list, and this allows you to extend the capabilities of your operating system. Additional repositories can be added by using the add apt repository command or by listing another provider, So for example, some vendors will have a repository that's closer to their geographical location that you can use. Managing the repositories, so adding and removing repositories, is done through the apt command. The apt command is part of the package management software, also named apt, and it contains a whole suite of tools that allows us to manage the packages and sources of our software and to install, remove software at the same time. One method of adding repositories is the add apt repository command that we illustrated, but we're going to walk through something else that is I think it's more commonly used. You can install software through the package installer like dpkg dpackage. The benefits of apt means that whenever we update our system, the repository that contains the pieces of software that we also add gets checked for updates. So in this example, we're going to add the text editor Sublime Text, which is really useful for writing code. And the repository, as it's not part of the default Ubuntu repository, so you have to add it and install it. When adding software, the integrity of what we download is guaranteed by the use of what's called the GPG, the GNU Privacy Guard keys, which is essentially the hash keys that are associated with each download to just make sure that it's legit and it hasn't been tampered with. There's safety check from the developer saying, here's the software. If the keys don't match up, then our system trusts on what the developer used, then the software will not be downloaded. So to start, we need to add the GPG key for the developers of Sublime Text. Note that the instances don't have internet access, so we can't actually do this. So this is just a sample of what you should be doing. So you're going to download the GPG key and use the apt key to trust it. So wget, as you already have gone through, wget, and then this is the, I believe, quarantine 0, so you're not quarantining it. And then this is the link itself, and then sudo apt key add, right? So you're going to get it, and then you're going to add it to your apt key. Now that we have this added to our trusted list, we can now add Sublime Text 3's repository to our apt sources list. And a good practice is to have a separate file for every different community third-party repository that we add. So in this particular case, it would be the etc apt sources list, and you enter that. So you create a file named Sublime Text list in this particular source list, and then enter the repository. So touch Sublime Text.list, then you ls, you see that it's here, and then you can go and add that to the repository. And the way that would look is that you can use Nano or any kind of text editor to add and save the repository into the new file. And it's this full line that you need to add in here, which means deb for Debian, https download-sublimetext.com, apt stable, make sure that it's all good. After we've added this entry, we need to update apt to recognize the new entry, because it won't just by saving it. So you need to update it to make sure that it registers and indexes in your system. This is done using the apt update command. Once it's been updated, we can now proceed to install the software that we've trusted and added to the apt using apt install Sublime Text. Removing packages is as easily as reversing the process. So you go to add apt repository, the option is remove, and then you remove whatever the name is. So for example, by manually deleting the file that we previously added to, once removed, we can use apt remove the software name, in this case Sublime Text. This seems like a long series of commands, But you have to keep in mind that this is for a command line only operating system, or a command line version of this operating system, right? There are other ways that you can download things that are a little bit simpler. This is something that a security professional would do to make sure that the system runs smoothly every time that it's been installed and reinstalled, or excuse me, installed and ran, and then when you reboot it and run it again, you just want to make sure that you have no problem, so that once it's set up, any user who's not a Linux administrator can just use the software like Sublime Text without having to worry about any of that information. So this is just a read-only portion, and it does seem like a lot, but it's something that will make more and more sense to you as you go through installing packages and getting much more familiar with becoming a Linux sysadmin. So finally here we have the system logs. So let's talk about log files. As we covered in the part 1 of our Linux Fundamentals series, the logs are located inside the var_log directory, and they contain login information for applications, authentication, services, a bunch of things. So the OS has become pretty good at automatically managing these logs, and it's called rotation or rotating. And these are some of the logs from the 3 services that are running on an Ubuntu machine. So an Apache 2 web server, the logs for the failed to ban service, which is used to monitor attempted brute forces, and the UFW service, which is used as a firewall. So the UFW is U firewall, and then failed to ban is used to monitor attempted brute forces as an example. So it monitors a few other things as well. And these are what they look like, right? So once you go inside of the actual log directory, you can see that there's a bunch of logs here. Apache 2 is one specific to the Apache 2 server. You have failed to ban, which is a series of logs that they just keep getting bigger and bigger, it seems like, or as the file type reaches a certain size that's been previously dedicated or previously declared, then that specific file type will create another file type, or with just another increment to it. So 1, 2, 3, 4, etc. And it'll just keep creating those until you go through your system and start deleting them. And then the UFW belongs to the firewall, right? These services and logs are a great way in monitoring the health of your system and protecting it. Not only that, the log services such as web server containing information about every single request, allowing the developers or administrators to diagnose the performance issues or investigate an intruder's activity. For example, two types of log files that are of interest are the access logs and the error logs. So if somebody tries to access something, or they have an error logging in, for example, and they get an error message saying such and such password is incorrect, and if you see too many of those, that's a red flag to think about. If an access log has gone through certain access from a geolocation or IP address that shouldn't have access to it, or attempts for access have been made, so on and so forth, all of that is very, very useful information for a system administrator or an incident responder that's trying to backtrack what just happened. There are, of course, logs that store information about how the OS is running itself and actions that are performed by the users, like authentication attempts. And again, logs by themselves are massive topic, and so you can go and learn a lot about them. This is just an overview of where they're located and just a few of these log types. So we're going to look for the Apache logs on the deployed Linux machine, and what is the IP address of the user who visited the site. So let's see. Let's go into our logs here. So we can exit out of this piece right here, and then we need to go to the var log directory, and we're here. And so we need the user, the Apache logs on the logs in the deployed machine. So the Apache logs right here. So let me see if this is a file. No, it is a directory. So we have a list of access logs that are here. So we can do, let's see, I'm going to grep for the user who visited the site. Which site though? That's the thing. So it doesn't tell me which site they want me to find. So I think I can kind of just look at the entire file itself. So let's see if we cat the access log. Let's see how massive it is. Oh, permission has been denied. Interesting. I can't even access that. That's interesting. So, okay, so let's see if we can cat the access log.1. Okay, we have one item from access log.1, and it shows that this is the IP address of the person that tried to access it. So very good. This is the IP address right here. And it says what file did they access. So you can look at everything else. So you have the IP address of the person, you have the timestamp that they tried to do, and then everything inside of the quotes in this first portion, or right here, actually it ends right here. Everything inside of the quotes is the request that they made. So it was a get request of the cats and dogs JPEG file, and the message was successful. So the request was successful. 200 is a HTTP response code for a successful request. And then this was the user agent that they used, which is Mozilla Windows NT, Apple WebKit, so on and so forth. Safari was the browser, all of that, right? So the request seems to be a get request for a specific JPEG file. And that's all we needed to get, which is right here as well. So it was inside of our Apache log.1, which is accessible to us and everybody else, it seems. The access log, the very basic one right here, was not accessible by me because I am not in a sudoers file, and there was an incident that was reported to my system administrator. So there we go. And that is it. That's all we got. That's all she wrote for this particular task and this course. So we just wrapped up the Linux Fundamentals Part 3. So this was very much an overview of Linux. You can imagine that this is nowhere near what you can do with the Linux operating system. It is a massive, massive operating system. There are so many different distributions to Linux, and there are so many different purposes that a Linux operating system can serve that just you can specialize in literally one version of the distributions that are available, and you'd probably spend over a year just trying to master it. So this is not something that you can get overnight, and this was very much a fundamentals series of videos that we did for this one, and it was just a part of the cybersecurity 101 pathway of TryHackMe. So it's important for you to understand that this will not happen overnight, even though I'm going to release the Linux Plus CompTIA Linux Plus certification series, and that entire video is going to be very massive, and we're going to cover everything from the basics to advanced scripting. So all of those things are going to be covered, but it'll probably still take a lot of time for you to really wrap your head around it and become masterful at this particular operating system, which is okay, because you don't need to be a master to get a job in the business or to get good at the things that you need to do. As a recap, we went to the terminal text editor, general utilities like downloading and serving contents with a Python web server, look into processes and maintaining and automating your system with the use of cron tabs, package management, and even reviewing logs. There is the bash scripting room, and there's a regular expressions room. I want to say that I've already done the regular expressions room. I definitely have. So there is multiple sources available for you. You can just go check out the regular expressions video that's on this channel, and you can just search for regex or regular expressions on the channel homepage. And the bash scripting room, I don't think I've done. Let me see. I have actually done this. So bash scripting, we've already gone through as well. I don't know if this was a part of the fundamentals. I think it is actually a part of the fundamentals. So we're going to be going through those rooms in a little bit anyways, but you can just go try to find them. If you don't find them, make sure you subscribe and turn on the notification bell so that you get notified when those videos do come out. But for now, we are officially wrapped with this particular Linux Fundamentals Part 3 room. If you found this video useful, if you would like to get more videos on the CySec 101 Cybersecurity 101 series, I do recommend that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this particular pathway. We already have multiple videos that are out. By the time that you see this videos, there will be even more videos that are out for Cybersecurity 101. So this is an important pathway. A lot of people have requested it because it does provide the groundworks for everything else that's on this channel. Because this channel, when I came into creating this channel, I was already into like the intermediate level stuff, and I was going into the advanced stuff. So I think it's very important to have the Cybersecurity 101 playlist, as well as the Cybersecurity 101 training series. So this is exactly what that is. And if you want to continue down this path, I do recommend that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out in this path. And of course, as we go into the advanced stuff, you'll also get pieces of those as well. And you'll be able to get to see all of those videos that come out. I don't mean to say that you're going to get a piece of the video, you're going to get full videos, but you'll be able to see the pieces of the advanced rooms and the tactics and so on and so forth. I feel like I'm probably not pronouncing that or explaining that very well, but I do give full videos. I don't do partial videos. I will do full videos of each tactic and each room, and then it'll be a piece of the full pathway. I should probably say that. So anyways, like, subscribe, turn on the notification bell, drop a comment, say hi, say thanks if you want to. I appreciate gratitude. Gratitude means a lot to me. But definitely just drop a comment. If you have any questions, let me know. I'll respond to all the questions that come in the comments. And if it's a big question, I will respond with a video so that you get a really good answer for it. And of course, there is the Hackaholics Anonymous membership community, which is the premier YouTube community for cybersecurity and pen testing. And it's literally, there's a lot of perks that are attached to this. This is my baby. It was something that I am very passionate about, and I want to make sure that you have access to a lot of extra tools that are not necessarily available through the other channels on YouTube or the various platforms like TryHackMe and things like that. There are certain things that as I was coming up, I realized that don't exist. For example, exclusive manuals or cheat sheets or Python automation scripts that can do a lot of things for you as you go into get a job as a system administrator or get a job as a security analyst. All of these things are available, and I give them away as a membership of the Hackaholics Anonymous community. So the first tier is our cyber support. It starts at $4.99. You get access to the Discord. There's like perks that you get access to, and then there's the special perk of a Discord server that's been designed just for that group, that you get access to me directly. You can message me or message all the advanced members that are in that group, and you have somebody to be along with you as you go down this journey of cybersecurity, as well as all the other good perks that come with having your own Discord server that communicate with somebody like us. And then there's the advanced memberships that you get the Python automations, exclusive content, manuals, etc., etc., etc. There's a lot of stuff. So if you go through the video right here, it explains all the perks for you. If you don't want to watch the video, you can just click the read more button at the bottom, and in the description you'll see all of the breakdowns of all the perks that are available as well. So that being said, make sure you check out the Hackaholics Anonymous community, which is the premier YouTube community for cybersecurity professionals and hackers. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next video. Later.